I hope everyone online can hear us. Welcome back, or welcome to. Thank you for coming to Florence. We're here on the second day of AnthroFlor at the University of Florence, and we have a busy day ahead of us of discussion and presentation. We're going to start now with a recap and scope for the day, led by Professor Jan Zalasevic, who is in the UK, currently online, and he is the chair of the Subcommission on Quaternary Stratigraphy, and he's just going to provide a quick recap of, I think, yesterday's discussion and what we were talking about, and just like and how we're going to run through today and the sort of themes we're going to be covering. Martin Head, who is here on my right, is the vice chair of the SQS, and he will also be contributing as well for the next 15 minutes or so to Jan's talk. So Jan, I hope that's okay for you. If you could, can you hear us?
Yes, thank you, Simon.
Awesome, thank you.
Greetings, everybody. Yes, this recap will be indeed shared by Martin and me. I will briefly go over the morning, and then Martin will take over to do the afternoon, and then between us, we'll just try and briefly introduce the events of the day in that. So it was, I thought, a very thought-producing, successful day yesterday. Started by Adele, wonderfully introduced, with what I think should become, one of the great quotes ever to come out of a conference. Adele said that the Anthropocene, whatever it is not a sarcopone. A sarcopone being an imaginary monster made up for a comedy series to frighten people. And I thought that struck home with me nicely, and it should be widely restated in that. And the kind of evidence for the Anthropocene not being a sarcopone was then summarized very clearly by Colin Waters, the current chair of the Anthropocene Working Group, who went through the beginnings of this concept, essentially improvised by Paul Crutzen at a meeting in 2000, when he said that stop, we're talking about change in the in the Holocene, but we're not in the Holocene. Because things have changed too much, and he, improvised on the spot the term Anthropocene, from which all of this subsequent work and discussion meeting has sprung. And there are just a couple of things it might be worth emphasizing from Colin's presentation. One is the way in which in the early years of the working group, the attention was focused on a kind of industrial revolution beginning, end of the 19th century, that kind of thing, and it wasn't working. Not stratigraphically, it was worked as history, but not as stratigraphy, as something that correlate. And only when attention switched to the mid-20th century and the Great Acceleration, that the stratigraphy began to fall into place very effectively and consistently. And then the three presentations after Colin's introduction demonstrated this very nicely. And started by Andy Cundy, who introduced the way that radionuclides, particularly artificial radionuclides from the bomb spike and others, can be used as a marker for the Anthropocene. And again, Andy emphasized that radionuclides had been used already for decades for a number of different kinds of scientific analysis to look at various aspects and to constrain various aspects of the Earth system. You know, this was already a mature science, which now most recently has gone to helping to provide a definition, not a complete characterization, but a definition for the Anthropocene. And then Neil Rose, I think, demonstrated again another aspect of the way that new evidence has appeared since the introduction of the term the Anthropocene, since the establishment of the Anthropocene Working Group in 2009. A few years later, several key pieces of evidence emerged, and certainly the way that the fly ash story was put together, largely worked out indeed by Neil and his colleagues, and put together to show this as a striking new proxy, a very distinctive one, a unique one, as he says, and one that can be used worldwide. And the third presentation of that series of three on proxies showed how a very old stratigraphic technique, that of biostratigraphy, perhaps the oldest, can be refashioned to adapt to a very new kind of timescale, one that works on decades and even years, rather than millions of years. And this was demonstrated by Mark Williams, who was the original secretary of the working group, and he and his colleagues have indeed pioneered the use of this ultra high resolution biostratigraphy, largely based upon the way that species have been taken from one part of the world to another, and indeed the biosphere has been homogenized to produce a new kind of stratigraphic signal. With that, breaking up at lunch, I'll now pass over, if I may, to Martin to continue this recap of the day.
Thank you, Jan. We're just going to change the seating arrangement with Martin.
Thank you very much, Jan, for those comments. I've been involved in timescale research for quite some time, and I've seen quite a few GSSPs. I've spoken to quite a few people about timescale research. Some people, a number of people, really appreciate the work that we do generally in producing and refining the timescale. I mean, really, when we think about the beginnings of geology, it's often said that the geological timescale was the crowning glory of 19th century geology, which I think it was. And of course, we continue to refine this timescale. Not everyone appreciates it, especially in the Quaternary, of course, where I think it was Nick Shackleton himself who famously said, I don't see that we have any real need for subdividing the Pleistocene. And from his perspective, you can understand where he was coming from, because we have marine isotope stages, we have various kinds of radiometric dating. Why would we need the time scale? Well, I think we need it for a number of reasons. One, just simply for the descriptive purpose of breaking up geological time into bite-sized pieces, so that we can sort of explain broadly what we mean when we're talking about a particular interval of geological time. We have a name for it, a label, that is useful in itself. When you're trying to explain geological time to students and members of the public and other people, it helps if you can break the narrative of Earth history up into rational units. And that really is what we've been doing with the Quaternary. But there's another aspect which I also find fascinating. And let me just say, first of all, though, that that a lot more is read into the geological timescale and into boundaries than we really intend them to bear. It's really just a method of conveniently helping to improve communication within the earth sciences. So, for example, when we subdivided the Holocene into formal lower, middle, and upper, it was because people were using those terms in imprecise ways because they hadn't been defined, and one person's early Holocene was another person's middle Holocene, and it invited confusion, which I hope we managed to eradicate by formalizing those terms. Something that people don't seem to realize with the geological timescale is that when you define a boundary, you are consigning all geological events and happenings to one side of that boundary or another. And at some point, when you get to find enough resolution, then that boundary becomes somewhat arbitrary. It's the case, for example, with the base of the Megalaeon. The Megalaeon runs through human history and archaeology, and it's just how it works in timescale research. That is how the geological timescale works. If it seems arbitrary
Bon,
at
les
some
enfants, on va mettre les chaussures. Nicolas et Mathieu.
If it seems arbitrary at some point, it's because, at a certain scale, it often is. The other, it's just a feature, an intrinsic feature of the timescale. One of the other things that I find interesting about timescale research is that it focuses our attention on interesting parts of the geological record where there has been typically a major change. And I think we saw that yesterday with the presentation of these various GSSP candidates. We saw this tremendous focused detail on a certain part of Earth history spanning the Great Acceleration, where we can see the geological record actually paired with historical and instrumental records as well, showing changes, significant changes that occurred in Earth history in tremendous stratigraphic detail that compares with any other boundary pretty much within the timescale. I would say personally that if there was any doubt about the stratigraphic reality of the Anthropocene, all you need to do is look at some of these candidate GSSP proposals. I don't know how I'm doing for time. Well, then time to wrap this up. Looking very much forward to today's events. Yesterday was more description about GSSPs and about stratigraphic indicators. Today's program is more to do with the conceptual aspects of the Anthropocene and of course, plenty of time for discussion, which I very much look forward to. Thank you.
Thank you both Martin and Jan for that recap and scope for the day that we'll be running through for the next few hours. So coming up now is Colin Waters, the current chair of the Anthropocene Working Group, who will be providing evidence for and implications of the termination of the Holocene. We'll try not to have people talking about cars in French. I think it was French during the meeting, but yeah, someone's shoes were missing, I think, in that. Okay, Colin, okay. Thank you.
Thank you, Simon. So Martin's always keen to indicate that really chronostratigraphy is a normative science. It's at the end of the day, placing boundaries relies upon us making subjective decisions. But I think the important thing is those decisions are made on high quality data. So what this presentation is just recapping perhaps many things we heard yesterday about the data sets that we're using to try and demonstrate the evidence that we have a termination of the Holocene and we're now moved into a new epoch. So a lot of the information I'm presenting in this talk is based on this paper that I mentioned yesterday, which was published in Science. The Anthropocene is functionally and stratigraphically distinct from the Holocene, published in 2016. And so it runs through a number of key signals, so novel materials, and I'll talk today briefly about aluminium, concrete, fly ash, and plastic. Changed flux of sediments, so artificial deposits and fluvial systems. Geochemical signals, so carbon and nitrogen cycles, those proxies related to climate change, and then the radiogenic fallout signals. And then finally, the biological signals that we heard from Mark yesterday. So to start with, this figure shows the cumulative production of both aluminium and concrete. So aluminium in red, there's been 500 million tons of aluminium produced. 98% of that has been since 1950. Aluminium as a metal does not exist naturally, so all of it's been produced anthropogenically, and say 98% of that has been since 1950. Concrete, we know that the Romans produced concrete 2,000 years ago, but again, the majority of concrete produced, which is now 500 billion tons, has been since 1950. In fact, about half of the productions occurred in the last 20 years. And annually, we're producing about 26 billion tons of concrete per year. And as we heard from Jai's presentation, that greatly exceeds the amount of natural movement of sediments from the land to the ocean. So it's an immense scale of production of just one element, concrete. We heard from Neil Rose yesterday about these spheroidal carbonaceous particles, and he demonstrated that there's in the region of about 25 trillion particles produced per day for one typical power station. So these are in great abundance, and they are also a stable component now of many of the sediments across the planet. They're distributed aerially. The emissions can be raised quite high into the atmosphere and distributed on regional continental scales. And Neil's work, looking initially at about 75, 76 lakes across the planet, recognized this pattern that though they initially developed, certainly in Western Europe, in about the 1830s, 1840s, they hadn't existed previously, but present in relatively low concentrations until we see in the 1950s a very marked upturn in abundance. And there's been this sort of phase between about 1970 to 1990 where we have a peak in their production, and subsequently, partly because of arrested technology to ensure that these are not distributed into the atmosphere anymore, we had seeing a downturn in abundance of these. So it's a very short interval where we're seeing SCPs in great abundance. Plastic production. So plastics in 1950s, annual production was about 2 million tons. By 2014, it was 380 million tons. So that exceeds the mass of all the humans on the planet produced in 1 year. The latest data I found for 2020 is about 367 million tons. There seems to be a drop partly because of COVID, but there's no evidence at present to say that this curve will continue. In fact, the little box you see on the top left is estimates of future production, which may be getting up to about 1,800 million tons per year. But what we do know, from 1950 to the present day, cumulative production is about 8 billion tons. That's double the mass of the entire animal kingdom produced in 70 years. And these plastics are getting into the environment in huge numbers. We're seeing only about 5% of all the plastics being recycled. Many of them are getting into the environment in the form of microplastics. So these are things like synthetic fibers, partly from washing things like clothing, and also polyethylene microplastic beads. These are sort of the standard product of how plastic is then produced from these nurdles, as they're known. But they can also form by secondary processes of breaking down macroplastics into microplastics. So these are on the scale of sub 5 millimeter, but many of them are much smaller than that. In fact, some of the synthetic fibers are known to be distributed aerially as well. So they're becoming a very widespread signal, particularly in the oceans. One of the good things with plastic, or maybe the bad thing of plastics, is that they do represent an equivalent of a fossil. They have fossil ranges, as you would do with any paleontological signal. If you're very lucky, you get a plastic that has a date on it, as you see on the top left, and that would be ideal as a paleontologist to have a fossil that gives you its indication of its age. But also, you'll see just maybe at the very top of that photograph of the plastic container, it has PP written. All of the plastics indicate what they're made from. In this case, polypropylene, PP, and you see from this range chart that polypropylene was first produced just after 1950, so about 1960 through to the present day. And it's true for most of these plastics that within about 5 to 10 years of 1950, most of them are produced. Viscose and Bakelite are older, from about 1900s onwards, but majority have been since about 1950. And of course, you don't have to have the symbol at the top there to tell you what it's made of, because there are now techniques, things like Raman spectrometry, which allows you, even for microplastics, to indicate what these microplastics are made of. So we can use this range chart and say that this indicates that we're within the range of the Anthropocene. So very, very useful markers for defining the Anthropocene. This was touched upon by Jai Savitsky's talk yesterday. This is looking at the production of artificial human-generated deposits. And this is data from 1925 through to 2015. It's production information, and it's broken down by color. So the pale blue represents mineral and metal production, plus the waste or overburden associated with that quarrying and mining procedure. By far and away, the greatest mineral exploitation, excavation, is coal. That's shown in orange. And so that figure there is plus the mineral itself plus the overburden and waste that's been produced. And then the third category is grey, and that's cement and aggregate production. And I mentioned previously about concrete production. That's obviously related to the cement and aggregates. The yellow represents offshore dredging, and then finally civil engineering earthworks in blue. And so looking through the data sets, it's clear that there's this incredible increase in the production of these materials from about 10.5 gigatons through to 316 gigatons in 2014. So that's a 30-fold increase over that period of time. And in 2014, we're talking about 150 cubic kilometers of material being produced per year. And then we heard from Jai again yesterday about the natural fluxes of sediment from the continent through to the oceans. And the scale of those, if you go back to 1950, the production of these anthropogenic deposits is about half of the flux of these sediments. Whereas by we get to 2014, it's now 18 times more. So if there's anything that gives you an impression that humans are really a geological force, we are now moving so much more material than natural processes are. It clearly indicates we are terraforming the planet. And Jai also mentioned about the importance of decreased fluxes to the oceans as a result of things like dam construction. So there's about 58,000 large dams, those in excess of 15 meters in height. Most of those have been built since the 1940s at a rate of 2 of these per day. And of course, that's having a great great influence in the amount of sediment being transported through the system into the oceans. And it's estimated that these reservoirs have impounded about 3.2 trillion tons of sediment over this period of time. To give you an idea of the scale of that, that's about 5 meters of sediment spread across the whole of Spain or the whole of California over a 70-year period. So we've talked about this previously, the carbon dioxide and methane concentrations as recorded in Antarctic ice core. We've got data now going back 800,000 years. And it's instructive to look at the range of things like carbon dioxide within that ice core. It ranges for about 170 to 300 parts per million over that 800,000 years, until you get to the very right-hand side of the figure. So the red and green there is, in effect, the Anthropocene, taking the values way outside of that natural range that we've seen. So it's 125 parts per million rise, and it's a rate 100 times faster than the increase at the Pleistocene-Holocene transition. Similarly for methane, the natural variations within the ice core are between 350 to 800 parts per billion over the last 800,000 years. And again, on the right-hand side, we see the Anthropocene component way outside of that natural range. So it's been a 1,100 parts per billion rise. That's 257% of pre-industrial levels. We can also look at the nitrogen cycle. So this is the blue curves here from 2 Greenland ice core nitrate concentrations. There's a degree of variability with time, but there's a clear transition around about 1950 where we're seeing eventually about a doubling in the concentrations of nitrate in the core. And that's, to a large extent, driven by what we're seeing with the red curve, which is production of artificial nitrogen fertilizers from the Bosch process. So there's a clear link here to increases in fertilization related to agriculture, but also the dashed line are nitrous oxides and NOx being emitted from use of the combustion engine. So again, that's adding a significant contribution to the amount of nitrates and nitrogen in the environment. And it's also true with phosphorus as well. Certainly increased mining of phosphorus is resulting in another doubling of the amount of phosphorus present in the environment. This work by Holtgrave et al. In 2015 for a number of North American lakes shows, and it's something that we're seeing consistently as well in the studies that we've been involved in, is that the stable nitrogen isotopes are perturbed significantly during this phase of production of artificial nitrogen fertilizers. So there's an initial dip in the stable nitrogen isotopes around about the last decade of the 19th century, but then a significant deflection down to lower values from about 1950. Anthropogenic climate change, this is largely data coming from composites from dendrochronological studies, but it indicates that there's been about we know from recording data that there's been a 1 degree global rise in temperatures from 1975 to 2020, and that departs from a 7,000 year trend of falling figures. So the rate of rise that we're seeing is about 0.02 degrees centigrade per year. That's almost an order of magnitude faster than at the onset of the Holocene. Obviously, the scale of change is not as significant as it is at the beginning of the Holocene, but the rates of change are greatly more increased. And it's also been proposed that current temperatures now exceed the Holocene thermal maximum from about 7,000 years ago. And so when you look at this work from Clark et al., it's showing obviously the last 20,000 years of CO2 values and inferred temperature change in the lower panel. And you can see that the Holocene represents a moderately level, unvarying succession of values, both in CO2 and temperatures. CO2, as we discussed yesterday, Bill Ruderman's indication that about 8,000 years ago, there's a slight upturn in values, but clearly what we're seeing today is a significant and unprecedented increase in CO2 values. And similarly, temperatures are showing significant rises as well. Based on forward modeling of what we expect, even if we add no more CO2 to the atmosphere, then we're expecting a plateauing of values for both for CO2 and temperatures, which way exceed those seen during the Holocene. So we've shifted to a new planetary state that, in this figure, we see persist for at least 10,000 years, so the duration of the Holocene repeated again, but clear indications that this is persisting potentially for up to 50,000 years, and with future additional additions of burning fossil fuels could result in a delay of the next glaciation by at least 100,000 years. We had a presentation from Andy Kunde looking at the radiogenic fallout signal, so there's not much need for me to repeat a lot of the content here, but this is just looking at the radiocarbon signals in green, which show a doubling of the amount of radiocarbon present in the atmosphere by the peak time of about 1964, 1963. Obviously, it's a natural component of the atmosphere, and the detonations have produced a doubling of the amount of radiocarbon, but it's the increase around about 1955, which is a very useful marker for the onset of the Anthropocene. But plutonium, which is not, well, pretty largely absent naturally from the environment, is very responsive to the detonations that we've seen, particularly the hydrogen bombs from 1952. So we can see that the black columns represent the aggregate yields in millions of tons or megatons of detonations, and that the blue plutonium signals very much follow the scale of those detonations. And so we have an increase around about 1952, very soon after the Ivy Mike detonation. We see a small dip related to the moratorium, so about 1959, 1960, and a peak in 1963, the year after the peak detonations, and then very rapidly it falls back down to almost to natural levels again in a short period of time. So we have a very short interval here, about 15 years, where we have a very clear perturbation of signals resulting from these detonations. So it's a very clear signal which we can use to define the base of the Anthropocene. And then we heard from Mark yesterday about some of the biological signals, and I showed this presentation of mammal extinction rates. So just to emphasize that though extinctions of megafauna is very much a discussion point, it's clear that we are seeing orders of magnitude increases in the rates of extinctions, but probably also importantly, populations of species are decreasing greatly in the last few decades. When it's a case of something like 60% of population decrease since 1970 has been recorded by the World Wildlife Fund. And then we had discussions about the introduction of new biotic species, and I showed this presentation from the work of Siebens et al., showing a clear recent mass movement of species across the planet. This is unprecedented amounts of change. A lot of it happened from about 1800s onwards, but again, significant inflections around about 1950. So just to sort of summarize all of this information in this one figure, what we have is sort of a clear increase happening around that transition between the Pleistocene and the Holocene, but which is generally slow and progressive over thousands of years. And then during the Holocene, it's pretty much a plateau. We're seeing a fairly consistent, unchanging set of signals here until we get to around about the 20th century, when we see these major deflections in the signals. So, for example, CO2, the rise that we see between 8,000 years ago and 1750 is about 0.003 parts per million per year. Since 1950, it's down 2 parts per million per year. So it's a 600 times increase in the rate of change. For methane, the rise from about 5,000 through to 1750 CE is less than 0.001% per year. Since 1950, it's 0.5% per year. That's a 500 times increase. For the N2O, we're seeing a rise between 10,000 years and 1750 of 0.001 parts per billion per year. Since 1950, it's 0.64, 640 times faster. So again, it's incredible scales of change that we're seeing. And temperature changes 1 degree since 1970, 170 times faster than at the the change that we've seen in the last 7,000 years, and in the opposite direction, it's warming rather than cooling. And if we concentrate then at the signals around about 1950, again, these show a consistent pattern of deflections around 1950, give or take a decade or so. So we have, mentioned before, but the CO2 shown in black, the methane in green, SCPs in pink, and also then the deflections in stable carbon isotopes. There's a consistency here in patterns of around about 1950, but there is a degree of variation, particularly globally, that has a variation of about 10 years or so between the northern hemisphere and the southern hemisphere, say. Similarly, temperature changes have generally been since 1975. During that critical interval around about 1950, there's a degree of stability in temperatures. They didn't start increasing till some 25 years after our proposed start of the Anthropocene. But the one thing that's very marked and clear that coincides with a lot of this change is the bomb spike, and particularly the onset of it becomes a very clear way of expressing where the base of the Anthropocene is. But that's not the reason why we're that's not why we're defining the Anthropocene. It's just a very clear marker. It's the other changes that we're seeing in this figure, all happening around 1950. It represents the change to the Earth system, which is modifying the planet to an extent we are no longer in that standard Holocene succession. So we propose that the Anthropocene represents a series or epoch with currently an unnamed stage, which should be defined around about the mid-20th century. And as clearly that means that the Holocene and the Megalaean would then be terminated because of this definition. So in summary, we're seeing a broad array of novel anthropogenic materials either first appear or show marked upturns in the geological record around about the mid-20th century. Some, such as this SCPs, the fuel ash, and microplastics, are very widely distributed and make excellent markers for the Anthropocene. The rate of human modification of the land surface has intensified in the mid-20th century. All this has greatly increased erosion rates. The flux of sediments to the ocean has greatly decreased. The carbon and nitrogen cycles in particular have been abruptly perturbed since the 20th century. This and its effects on climate are outside of the Holocene norms and do not represent temporary blips. These are significant long-term changes, and in the case of the biosphere, permanent changes. So extinction rates and rates of translocations of species have shown abrupt rises over the past century, showing a transition to a new biotic state. And finally, signals are sufficiently strong and widespread in the geological record and reflect planetary rearrangement of sufficient scale to be used in defining an Anthropocene at the rank of epoch series, terminating the Holocene. So thank you very much.
Thank you, Colin. Yeah, so I don't think you could have done a better introduction of why we're linking or why the proposed Anthropocene epoch is related and linked to the Great Acceleration. And Martin Head is going to talk briefly, next 15 minutes or so, about why we linking the Anthropocene with the Great Acceleration.
Okay, it's a pleasure to be here. So I shall be talking about the Great Acceleration and how it links with the proposed Anthropocene. Okay, well, the Anthropocene, as we all know by now, was a term proposed by Paul Crutzen, in his words, to emphasize the central role of mankind in geology and ecology for the current geological epoch. I mean, he was very clear that he was intending the Anthropocene to be a geological epoch, a formal interval of geological time terminating the Holocene. He didn't say say things in exactly those terms because he was, after all, an atmospheric chemist, not a geologist. But it was clear, exactly clear what he intended the Anthropocene to mean. Now, he proposed the latter part of the 18th century as the inception for the Anthropocene, because during the past 2 centuries, the global effects of human activities have become clearly noticeable. In particular, he emphasized the increase in growth of atmospheric CO2 and methane. Well, he was an atmospheric chemist after all, but these are major drivers of Earth systems change. Now, the starting point, the inception of the Anthropocene is crucial, of course, because if you are going to have a geological Anthropocene, then the base has to align with the geological evidence, and indeed geological evidence that can be traced globally, synchronously around the world. Now, over the years, there have been a number of suggestions for the start of the Anthropocene. Not necessarily the Anthropocene intended to be a geological intended to be a chronostratigraphic term, but nonetheless. And these starting points range from about 50,000 years ago, possibly, to as recently as 1964. Now, Crutzen thought that the most reasonable starting point for the Anthropocene would be with the beginning of the Industrial Revolution in Europe. Well, the problem, of course, with that is that this gives you maybe a regional signal, but not a global signal, because the Industrial Revolution didn't start at the same time around the world. Well, it was in fact the Great Acceleration, a concept unfolded by Stefan and others in 2004 and 2007, which was an upturn in many socioeconomic trends and geological signatures, essentially stimulated by events occurring immediately after World War II, that prompted the suggestion that the Anthropocene should begin in the mid-20th century. Waters and others in 2015 thought that the rise in dispersal of plutonium-239 due to above-ground bomb tests at that time might be a useful stratigraphic guide, and of course that is consistent with a mid-20th century onset for the Anthropocene. Okay, so what then became eventually known as the Great Acceleration Curves emerged from an international synthesis project, the IGBP synthesis project led by Will Stefan, who is a member of the Anthropocene Working Group. Their work was first published in 2004, as you can see here, and the concept arose from data analysis. In other words, the concept of the Great Acceleration came from within the Earth system science community. And it was a recognition, basically, of overwhelming human drivers from the mid-20th century onwards, and, of course, the Earth system's responses to them. Now, these Great Acceleration curves, or graphs, as they became called, were first published in 2004, but published again and updated and somewhat enlarged in 2007 and again in 2015. But they started in 2004, before the term Great Acceleration had actually been coined. This is the version of the Great Acceleration curves from 2007, and you can see an upward deflection approximately around about the year 1950, sorry. Of course, there are individual exceptions to all of this, but we're talking about a general trend in an uptick around about 1950, the mid-20th century, in other words, characterized by large increases in the magnitude of human drivers of global change, as I say, most rapidly occurring from 1950 onwards. And of course, their impacts on the structure and functioning of the Earth system. The following year, that's after 2004, when the book came out, the following year in 2005, there was a workshop in Dahlem in Berlin, convened by Will Stephan, discussing these human-driven changes, the challenges to the globe, and so on. And it was a surprise, in fact, to Earth system scientists that there should be this sharp upturn in indicators and trends around about the year 1950. It had been assumed within the Earth systems community that there would be a gradual increase in these trends from the Industrial Revolution onwards. So it was a surprise to find things happening around about the year 1950. Now, this workshop included a mixed group of social scientists, natural scientists, and humanities scholars, including Earth system scientists and others. These curves, on the other hand, were not surprising to historians at this workshop. For example, the environmental historian John R. McNeill. He'd already studied the 20th century environmental history in his book, Something New Under the Sun, an environmental history of the 20th century. And it was John McNeill who coined the term Great Acceleration, echoing the Great Transformation, the term in the book written by Karl Polanyi in his 1944 societal analysis. So the curves and the concept behind these curves are actually underpinned by historical analysis, but nonetheless, they arose within the Earth system community. The term Great Acceleration, as I've just explained, was figurative. You know, it was not intended to be a precise mathematical term or concept or revelation. It was, it was figurative. Now, it's one thing to see this happening in curves, but since it had been proposed really at the outset that the Anthropocene should be a unit of geological time, it wasn't too long before the geological community started to explore the possibility in reality of this being a real formal geological unit. And a couple of important publications came out of this. It was in fact in 2012 that Zalasiewicz et al. Drew the link between the Great Acceleration and the Anthropocene. And since then, there have been a number of investigations geologically into whether that actually holds. These are summarized in a couple of very important publications. One published in Science by Waters et al. In 2016, and the other a book, a large book, summarizing all the evidence, The Anthropocene as a Geological Time Unit, edited by Jan Zalasiewicz and others. The chapters were mostly written by members of the Anthropocene Working Group. We've been through some of these indicators here. They include novel mineral-like compounds, in excess of 180,000 of these mineral-like compounds, fly ash, black carbon, microplastics, etc., etc. We've talked about these yesterday. Very, very clear, strong geological signatures aligned with the Great Acceleration. And in 2019, the Anthropocene Working Group recommended that the base of the Anthropocene be defined by stratigraphic signals associated with the mid-20th century, in other words, with the Great Acceleration. Now, there have been some misconceptions and misunderstandings that related to the Great Acceleration, and so in response to those, myself and colleagues from the Anthropocene Working Group, but also including David Fagerland, wrote an article trying to dispel some of these misconceptions and clarify what is really meant by the Great Acceleration. For one thing, rapid increases in growth cannot be sustained. This is impossible. You can't have acceleration going on forever. This was anticipated, in fact, at the outset. This curve is from Stefan et al. 2004, and it shows a rapid increase in a particular trend, and then you get, because acceleration can't carry on forever, you then get a slight slowing down. At that point, where you get a change in the curve, you get the inflection point. The inflection point, by definition, is the point of maximum acceleration, and that occurs, around the mid to late 20th century. But then, of course, you get a slowdown, which is an absolute inevitability, and that slowdown leads you then to several possible future outcomes, as you can see here, E, B, and C. This was anticipated right at the outset. What's really important is not the mathematical shape of the rapid rise in growth. It's the fact that it occurred, that there was a rapid rise in growth rates. But also, perhaps even more important, is the massive increase in magnitudes. These are key features of the Great Acceleration and their impacts on the planet. And they're not going to go away anytime soon, many of them. There are different ways that you can plot the Great Acceleration curves. The easiest one, I suppose, is just sort of plotting the quantity against time, as you can see here on the left. You don't need fancy statistics to see that there's an upturn around 1950 in these major drivers of the Great Acceleration. But you can also look at annual growth rate of, for example, energy consumption, GDP per capita, growth rates of population. And you can see, even on the sort of micro scale, you can see sharp upturns at or around 1950. The crucial thing is that these have all led to enormous increases in these particular indicators. Again, they don't all necessarily have to happen at exactly 1950 because of leads and lags in the Earth system. In the case of CO2, you can see a sharp rise in 1950, which continues to this day. It's not exponential, but you continue to see a rise, and that continued rise is very significant. As Colin explained in his talk just before mine. Then again, you get certain trends, such as, for example, total fish catches, which obviously cannot be sustained because there is a finite number of fish in the oceans. Fish stocks are finite, so you're going to get a tailing off, as you can see here, and in fact even a decline. You see the same with large dams around the world. At some point, you run out of large rivers to dam, So this is what actually happens. Again, because of feedback mechanisms within the Earth system, you get some lags, for example, in the case of global surface temperatures. These you would expect to start to increase around about 1950 with increases in CO2 concentration, but it doesn't happen because of various kinds of lags and feedback mechanisms and inertia, basically, within the Earth system. So, in fact, global surface temperature rise was disconnected from CO2 rise until about the 1980s for various reasons. We look at cement production, very important. It releases CO2, it increases sediment fluxes, and it produces an enduring rock-like substrate. So it's important to the Earth system, but it's also important to the geological evidence for the Anthropocene. Now, global cement production rates haven't increased since 2015. They've leveled off. But the important thing here is the amount of cement that has been produced, and it's still being produced at very, very large rates. And this has a cumulative effect on the biosphere, and of course on the evidence and the geological signature for the Anthropocene. And I won't go through all these numbers, but they show you relative increases of various indicators and trends since 1950, and you can see huge increases in all these important indicators. Now, the Great Acceleration actually is important also because it justifies the rank of the Anthropocene at the level of epoch. Because of the scale of change, the magnitude of changes. For example, atmospheric CO2, 146% of Holocene levels. This is the highest levels for the last 3 million years. Atmospheric, and that CO2 is really important because of its long residence time in the atmosphere. Atmospheric methane, 257% of Holocene levels, highest for at least 800,000 years. Reactive nitrogen, highest levels for 2.5 billion years, possibly. These represent fundamental changes to the Earth system state. And you can see here this illustration by Stefan et al., showing how the Earth has shifted away from its normal, natural glacial interglacial oscillations into a state that is a kind of near-permanent interglacial kind of configuration. It's often been said, well, you know, how can you have an epoch that only lasts 70 years? Well, you know, it's not long enough. We have to wait longer. We should wait for another generation. Well, why wait another generation? If you look at modeling studies of the Anthropocene, it shows that even under sort of moderate scenarios, we will be skipping the next interglacial. And this is because of two things: because of the long residence time of CO2 in the atmosphere, and also because we're at the moment at a low orbital eccentricity. So therefore, the present interglacial may last for, well, will last for at least 100,000 years. Do we need to wait 100,000 years before we decide that we've lived in a new epoch? And if we were to look back, we'd say, well, the Great Acceleration is actually when it started. We know that already. Possibly, this present interglacial could carry on for another 5,000, another 50,000. That's almost 500,000 years into the future, all right? So anyway, these are important things to consider when we are talking about formalizing the Anthropocene. So then, rapid growth in 1950 is inevitably time-limited. Obviously, it can't be sustained long-term. Even after 1950, however, growth remains positive and magnitudes remain overwhelming. Curve-fitting methods, I mean, you can fit a curve to anything, or you can define any curve mathematically. But what does it mean? The reality is that simple curve-fitting methods underestimate the complexity of anthropogenic drivers. You know, the Earth, humans do not present a gradual monotonic driving force. There are complexities that we already understand because we have a historical analysis underpinning these curves. The Great Acceleration aligns Earth system science with an evidence-based, concentrated array of stratigraphic event signals. Yes, we use event stratigraphy. You saw it yesterday. We're using event stratigraphy for defining the Anthropocene chronostratigraphically. The Great Acceleration provides the rationale for epoch rank, terminating the Holocene. The Great Acceleration essentially is confined to the mid-20th century, but the effects of it may last for 100,000 to maybe 500,000 years. I was at a conference last week in Bergen, a lot of modelers there, and they were saying that, well, actually, you know, within 100 years or so, we will have found the technology to sequester CO2 from the atmosphere, lowering CO2 levels. We're not going to do that to the point where we plunge ourselves into another glacial. You know, when we get to that stage, we will have essentially decoupled the Earth's climate from orbital forcing. And you know, this will be a continuing feature of the Anthropocene, this decoupling of the Earth from orbital forcing, which has already started and began in the mid-20th century. So the Anthropocene is not a blip. Thank you very much.
Thank you, Martin, for words unprecedented, not a blip. Outside of Holocene conditions, these are all aspects that we're looking at from the mid-20th century and defining the Anthropocene. We have an opportunity now for people to ask questions. Yeah, please take a seat, Martin. We have people now, if there's people online who'd like to ask a question, and if there's anyone here in the audience, if they'd like to raise a question or comment, that'd be good to hear.
Martin, it might be best to go back to the lectern because there's only the one mic.
Oh, yeah, okay.
Anyone got a question in the room? No? Anyone online? Please do, during the day, raise, I just sent a comment, just if you do have any questions or comments online and you'd like to raise during the day, please do let us know there, and we can chase you up during the day. We have a coffee break fast approaching, which I'm quite looking forward to. Colin, do you have any questions you'd like to, or raise anything that you've... Adele, would you like to raise it? Any questions you have? Okay.
It looks like I anticipated all those questions in my talk.
Yeah, there is. Let's see who it is. It's Lucy Edwards. Lucy, can you hear us? Would you like to ask your question online, please?
Hi, folks. Yeah, I can't let you just have no questions at all. Martin, thanks for a great talk. You have conclusively proved in my mind that the Quaternary is over. And your modelers last week said that the Quaternary is over, that we've switched out of using orbital forcing to mankind changing, humankind changing out of the ice ages. So what would you say is the Quaternary over?
If the Quaternary was over, well, let me just say this. I mean, I understand where you're coming from, and I certainly empathize in many ways with this. The reality, of course, is that if we were to redesign the geological timescale from scratch, knowing what we know now, the geological timescale would look very different from the way it is. Of course, the geological timescale carries with it a lot of baggage. I think it would be a wonderful exercise if somebody actually did try to redesign the geological timescale just as a thought experiment. In fact, it's something I thought of doing myself when I eventually retire, but that won't happen for some time. But it would show you just how far the geological timescale has deviated from, or rather how current knowledge has deviated from the geological timescale. It carries baggage. Part of that baggage, of course, is the Quaternary. It's been around for so long, since, well, 1760. It's been around so long that I think people would find it just, a revision too far to actually remove. No, it wouldn't be removing it. We would be terminating it, is what you would say, Lucy, I think. And I believe that would be just too radical. One of the reasons why we can't mess around too much with the geological time scale is because you then decouple our understanding of time with the older literature. So we have to, whenever we make changes, we have to do it, with a lot of careful thought. I think terminating the Quaternary, while there is some justification for doing so, I think that would be going too far. But I don't think it's going too far to terminate the Holocene, because I think it's very clear, to me at least, and to many people, that we really have escaped, if you like, for better or for worse, we have escaped the envelope of natural variability of the Holocene without question. That's my opinion anyway.
Thank you.
Also, to some extent, the justification for the Quaternary is the existence at both poles of extensive ice sheets. And we're still in that world. I don't know how much longer that will be true, certainly in the North Pole, but we are still in that remit of a bipolar glaciation and ice sheet. So I see no justification at this stage to say that we've gone outside of the extremes that we see within the Quaternary, but many of the signals are outside of the extremes we see in the Holocene. And that's the justification that the majority of us had to pick an epoch level. You can argue with time, then maybe both a climatic and biological argument to say that we've now transitioned into something even greater. We are not in a great extinction event at present, but we're moving towards it. So again, if we do get 70% of species extinctions, then maybe we should be revisiting the hierarchy, but that's not for our generation to discuss.
Thank you, Mary, for your questions. We have a question from the floor from Francine McCarthy.
Yeah, it's a bit of a response to Lucy's question, actually, and I was going to point out that the Anthropocene, the term Anthropocene is baggage that we've inherited from Paul Crutzen, in the sense that the sound of the name itself is at the epoch level, right? It isn't at the period level, it's not at the era level. Some people refer to the Anthropocene era. And the fact that Martin, I think it was Martin who mentioned the variable use of early, middle versus, early Holocene, meaning different things to different people. I think that's one of the major drivers for having at least a geologically, stratigraphically defined Anthropocene epoch. Whether or not social scientists and humanities scholars want to choose to use the word in variable terms, eventually the formal term will stick, in my opinion.
Thank you, Francine. There's a comment here from Michael Wagreich. Now, this is where I don't know my history of stratigraphy very well, but he suggests that we should remember the term quintaire was already suggested a long time ago. Martin, do you know what the quintaire was? Or maybe Michael, if you're there, could you elaborate on that?
The quintaire, I'm not really sure. Oh, I see. Is the question here?
I think it must relate to an early subdivision.
Oh, okay. Yes, all right. Sure. I mean, there have been a lot of terms that have been used to approximate what we mean by the Anthropocene. But in a sense, it doesn't really matter, does it, what you call it, as long as you call it something and you have a definition for it. Now, of course, the nice thing about the Anthropocene as a term is that it fits with the scene termination of the other epochs of the Cenozoic, so etymologically it works well, and that's one of the reasons why we're using the term Anthropocene. I think it's unfortunate that that word Anthropocene, which was clearly intended to be a geological term, has been sort of used by other constituencies and given different meanings. I think not that we own the Anthropocene as a term, but I just find it unfortunate that it has accrued so many different meanings, and I think that's a great shame because it just invites confusion as far as I'm concerned. I'm a great believer in, one term, one concept, because that just aids in communication.
Thank you, Martin. Oh, there's another question from the floor. Could you introduce yourself as well?
Oh, yes. My name is Silvia. I had a question yesterday as well. Silvia Danese, paleontology here at University of Florence. I was just wondering, after your last sentence, you said Anthropocene, it's like a geological term, but it happened during historical time. So what about if it was an historic term more than a geological term? And it was proposed by a chemist. This is what I learned today. Thanks.
So I didn't quite get that. It was intended as a geological term at the outset, and within the Anthropocene Working Group continues to be used essentially in the same way. I can't really think of a better term, to be quite honest, in terms of its etymology. It fits very well with the epoch terms that Charles Lyell proposed in the early 19th century. I think actually quite a lot of these conflicts that we're having with social scientists, for example, are because essentially everybody wants to use the same term. I think this is a big problem. I don't really understand why we need, why others can't come up with different terms. I don't understand. You'd have to ask a social scientist or a humanist why they are using the Anthropocene when there are so many other different versions of the different meanings for the Anthropocene out there. It's beyond my ken. I just don't understand it. But then I'm a scientist, and so for me, precision in terminology is extremely important. For me, it just makes sense that one term equals one concept, and I can't get my head around all these different kinds of meanings for the Anthropocene. It makes no sense to me at all.
Thanks.
There's another question here from the floor, please. Could you also introduce yourself as well, please?
Yes.
Thank you.
My name is Barbara Montecchi. I'm not an expert, I'm not a geologist, so my question may sound naive. I apologize for this. But I'd like to link my question to Silvia's question. Why the same term cannot be applied for both? So why Anthropocene can be used for both a geological epoch and an historical time span? Because Anthropocene refers to something we are experiencing now. If we accept that it began in the mid-20th century.
Well, because, sorry, was it for me to answer that, respond, or?
Yeah.
Yeah, sure.
You.
Shall I have a go at answering that, or? So, no, I'll give it to somebody else.
If it's geologists and social scientists using broadly the same understanding, that's fine. But clearly when you have a term, what we don't want to have to do is say, well, I'm talking about the geological Anthropocene, and you're talking about, say, the archaeological Anthropocene, one term, different meanings, is very confusing. And to have to keep explaining what you mean by your term defeats the object of having the term. And what we're finding is there's this contrary debate to say that it's all human impact on the planet, no matter how small, no matter when it was, is given this term. And that is clearly contrary to our understanding of this as being something that's happened in the last 70 years and represents massive change to the planet. So if you start to equate, we saw yesterday with Mark's presentation, a hand axe that was generated 20,000 years ago to cut down a tree, and equate that with a 50 megaton nuclear device exploded in 1963, and saying these are all part of the Anthropocene, that to me is quite confusing. And what is the point of this term, which is all-encompassing, all human impact? Where does that benefit us to understand that humans modified the planet 50,000 years ago? We know that. Does it need to have a separate term? Certainly archaeologists had not come up with an alternative term over centuries of their science. They didn't need it. And they have got terms like Bronze Age and Iron Age, which they've used, but even they are getting supplemented by the use of absolute timescales and even geological timescales because of their consistency in level. Whereas if you're talking about the Bronze Age, you always ask the question, but which Bronze Age? Are you talking about the Middle East? Are you talking about Europe? So it's important to have a fixed definition for a term. And this is where the Anthropocene, as a post-1951, to me, has to have the primacy of the fact that this is where the research comes from. And within geology, we have to have a very formalized approach to research and define these terms, whereas other specialisms seem to be able just to pick a name out of the air and define it as they wish without any formal procedure. So personally, I feel we have gone through that robust protocol, which we were asked to do, and surely that adds extra weight to the process we followed.
Okay. Thank you. Thank you.
We have another question from Flor. Francine, please.
Yeah, this is a response to your question. I work a lot with humanists, social scientists, and so on, and I totally understand your question. I think if you and I speak about the period since 1950, and we say Anthropocene, and you're an historian, and I'm an earth scientist, this is perfect. But I think the response that you're getting from Colin, for instance, is the loose use of the term Anthropocene. I mean Anthropocene starting in 1610. I'm an historian and I mean it this way. But to me, as long as there is a formal term Anthropocene, even if it's not quickly accepted by the other communities, that's the first step. And I think of the word Easter or Christmas, because there are two different dates for that, for people who believe very, very strongly. And in Poland, you would know this, that they're, so do you mean Eastern Orthodox Easter, or do you mean, Roman Catholic? So in terms of meaning, things having two different meanings, as long as we can link to some formal term. We say, well, I'm using it in the sensu stricto or the sensu lato, so at least then it means the same thing. And then the extreme opposite of, if I can identify human impact, then by definition, this is Anthropocene. This is the complete opposite of what I think any of us in this room probably want.
Thank you, Francine.
Jan.
Yes, just before we break for coffee and try and redefine the geological timescale, we'll just go over to Jan. Jan, do you have a question or comment?
Yes, just a very quick comment. Again, fascinating discussion. It struck me that it's important not to, if you like, oversimplify the idea of inter-community differences on this. There are, historians, John McNeill, not least, Jacques Greenwald, Julia Thomas, and others, who do use the Anthropocene and who use it in essentially the meaning of Paul Crutzen and the Anthropocene Working Group. And to them, the advantage of that is that it adds an extra dimension to their historical studies, just as the historical context can add an extra dimension to scientific and geological studies, and that ranges more widely. You know, there are other historians, Deepesh Chakrabarty, for instance, philosophers such as Bruno Latour, also when they discuss the Anthropocene, which they do quite frequently, their understanding, as far as I can work out, is that of this very, very recent change to the Earth system, and of course to human systems as well, rolled up in that. So it's an important, if you like, additional impetus to the study.
Well, we can start with the second part of this morning session, and our speaker is Guido Chelazzi. Is a professor of ecology, and he was president of the Faculty of Science and also president of the Natural History Museum. And today he will present the evidence for early effect of Homo sapiens on terrestrial biodiversity. Please.
Thank you, Adele. Good morning to all. And I want to express my gratitude to Adele for inviting me to this important symposium. I'm an outsider, but I am delighted to listen your considerations, and I feel that I will come out improved in my knowledge about the Anthropocene a lot. And as an ecologist and anthropologist, I find your discussion quite crucial, really. And okay, I'll give you a different perspective, not of the Anthropocene, but of the process behind the Anthropocene, okay? I will not try to give my opinion, because I cannot have an opinion on the specific theme, which is, I agree, a theme for geologists and stratigraphists, absolutely. But I will tell something from a different point of view about the process of human-environment entanglement. And I'll say something that you probably well know, but I'll give some considerations about all this. So we can start recognize that since the antiquity, human activities had profound effect on the distribution of plants and animals, and this has been also recognized by the classical literature. We have some awareness on this, also, for instance, in the Iliad of Homero, where the death of the hero Aegio, the Trojan hero Aegio, is parallel to the fall of an oak or poplar or tall pine under the sharpened axis, like timber, no? And in other parts of the Iliad, there are notations about the human activity on the forest clearing of the Aegean Mediterranean area and at the end of the Bronze Age and the beginning of the Iron Age. So it's well known since many times, but apart from Homero, an increasing concern for human environmental interactions in the antiquity and also in prehistoric times has marked the recent anthropological and ecological literature. An enormous amount of evidence, or claimed evidence, on the human ecological agency in the past has been generated by the recent enormous improvement in methodological questions, for instance, in paleoecology, using palynological and paleobotanical new proxies, or also by paleontology, by archaeology, including new methods based on isotope analysis, and why not archaeogenetics. A final result of this scientific endeavor has been the breakdown of the barrier between history and prehistory in the studies of human ecology, and the acceptance of a model of ancient deep rooting of the interactions between humans and the different dimensions of the environments they inhabited. But most importantly, this has favored the overcoming of the standard neo-Darwinian view of the external causation of evolutionary change, according to which the changing environment challenged the fitness of the organism, generating directional selection pressure and eventually controlling a progressive evolution, a progressive human evolution. The now emerging models, the new models which now are emerging in eco-anthropology, for instance, focus instead on the long-term circular relationships between the humans and the environment, ultimately controlling the transformation of both. So the externalist view of the standard neo-Darwinism is becoming substituted by that of a circular relationship between the environment and the humans. In this framework, the concept of ecosystem engineering and that of niche construction emerged as a part of a broader evolutionary synthesis which extended the neo-Darwinian approach to the human biocultural evolution. This is what is happening now. According to this extended model, the capacity for manipulating the environment is a structural component of the human profile, not a recent expression of it. And this argument, I understand, has been used by somebody also to enter into the discussion about the nature and the timing of the Anthropocene. The backward positioning of the onset of the Anthropocene began with the recognition that in the Levant and the Near East, forest clearing and plant community transformation were coeval with the appearance of agricultural societies. So we are speaking of something happened about 10,000 years ago, okay, before the present. Forest clearing impact on the natural communities and the spreading of plants and animals showing signs of domestication is very well documented along the Mediterranean coast and on one side, and along the inner trajectory of Greece, Balkans to the east, and then central northwest Europe, along with the archaeological, anthropological, and also archaeogenetic evidence of the migrations of early farmers from Anatolia, starting about 800 years ago. And in some cases, even the soil erosion and sedimental accumulation have been claimed. For instance, in the Danube Basin, following the diffusion of the farmers of the Lignyan band ceramic towards the Central Europe, suggesting a transition from very local to regional scale of the effects of human activity. But of course, forest clearing in continental Western Eurasia become even more evident, we know, during the late Neolithic and the following Bronze Age and Iron Age, as demonstrated by a lot of many different studies. For instance, this one of Roberts and co-workers of 2018. Following this evidence, it has been claimed that the endemic diffusion of the farmer society from the original cradles in Western Eurasia and the associated forest cleaning for cereal and legume cultivation has produced some detectable modification of the chemical composition of the terrestrial atmosphere, with the first reversal of the normally decreasing trend in CO2 concentration following the Pleistocene-Holocene transition. And similarly, it has been claimed that the diffusion of wet cultivation of rice from the Yangtze Basin to much continental and insular Southeastern Asia, and the consequent demographic growth of the farming societies in that vast area could have produced the first Holocenic increase of methane in the atmosphere around 5 millennia before the present. We know that since its first presentation in the 90s, the hypothesis of the late Neolithic onset of the Anthropocene has been hotly debated. On one side, Wally Breaker and others opposed the arguments of William Rudman for a link between farming diffusion and early atmosphere transformations. But on the other side, accumulating evidence on early pre-industrial deforestation and land transformation, reported, for instance, by Stephen and co-workers in their paper 2019, and several thorough contributions, for instance, by Earl Ellis, offered empirical evidence, empirical material for supporting the Rudman hypothesis. The extreme proposal on this line of anticipating the Anthropocene, to the linking it to the Neolithic affair, is that of Smith and Zeder, as you know, who in 2013 proposed to merge the Anthropocene and the Holocene. The idea to identify the origin of the Anthropocene with the appearance of agricultural economies, I can understand is appealing, can appear appealing, since it refers to what is considered a major discontinuity in the human niche construction process, the so-called farming or Neolithic transition. However, the modern archaeology, together with paleontology and paleoecology, tells us a different story from that imagined by the old archaeologists like Gordon Verechilde, for instance, who coined the term revolution for the appearance of the farming society. It's now totally evident that the Neolithic was another of the many revolutions that weren't in the long history of the humans. It's well documented that the farming transition was a gradual, complex, multicentric, and time-transgressing process, deeply rooted in the late Pleistocene. At least since the last glacial maximum in the western and eastern Eurasia, several local populations underwent cycles of demographic growth and crisis, mobility and residentialism, marked by local implementation of new strategies for ecosystem exploitation, often based on definite techniques of environmental manipulation. Far from being a sharp transition occurred after the onset of the Holocene, it emerged in several human populations of the last part of the Upper Paleolithic as a complex array of practices for the control of ecosystem productivity, based on incipient forms of wild animal and plant management. The American ethnographer Bruce Smith has efficiently called this long process as the no-man land, separating pure gathering, hunting, fishing societies from those we can define as full agriculturalists. From an ecological point of view, we can say that this complex transition was part of a wider and longer-term process of ecological niche construction in which humans were both transforming the ecosystem they lived in through an expanding activity of ecosystem engineering, and were themselves transformed both biologically and culturally by the modified environments they produced. The new ecological configurations produced by each generation and left in inheritance to the following generations paralleled the genetic and cultural inheritance, and the human environment entanglement became more tight and important for the transformations of both the humans and the planet. At least at the local scale, the effect of this early manipulation of plant communities are evident from palynological proxies, from traces of vegetation burning in pit bogs, in lacustrine sediments, and so on, at the local level. However, also proto-farming horticulturalism of the Epipaleolithic and Mesolithic did not emerge from nothing, but were rooted in the behaviors and practices of the Upper Paleolithic populations of hunter-gatherers. During their expansion from the African homeland, anatomically modern humans exploited a variety of ecosystems, from savannas to forests, from inland riverine habitats to marine coastal areas, including rocky, sandy shore, and even mangrove forests, for instance. There is a sparse but suggestive evidence that even in this early phase, humans used different methods to get easier and more efficient access to most profitable resources, including the control of vegetation using wildfires. There is pollen and charcoal evidence, for instance, that in the area around this beautiful cave, the Nia Cave in present-day Sarawak, where modern humans arrived since about 45,000 years ago, they, first modern humans arriving there, were using fire to maintain the plant community at a stage best suited for hosting the fauna of their own interest and to hunt this fauna. Hunting and habitat modification by humans have been claimed as determinants, as we know very well, of regional variations in animal biodiversity, particularly of large herbivores during the Upper Pleistocene and the First Holocene. Beginning in the 60s with the formulation of the famous overkill hypothesis by Martin and the objection posed to it by Leakey, the debate of human versus climate causation of quaternary extinction of megafauna has produced tons of papers and still holds bench on the major journals of paleontology, ecology, and anthropology, and is the subject for speculations, scientific disseminations, and so on. Far from reaching a general consensus, the scientific community still express some diametrically opposed models about this. We can see just two of the many examples of well-done, thorough studies reaching quite opposite conclusions about the role of humans in this affair of the megafauna extinction in the late Quaternary. In the papers of Barney Flannery, 2005, and the Copper and co-work in 2015. From the first paper, the conclusions, new observations emerging from refined dating techniques, paleoecology and modeling suggest that the megafaunal collapse of the Americas and Australia, as well most prehistoric biotic losses, island biotic losses, trace to a variety of human impacts, including rapid over-harvesting, biological invasions, habitat transformation, and disease. On the contrary, the conclusion of the second paper sounds as follows. Rapid climatic change associated with interstadial warming events are strongly associated with the regional replacement of extinction of major genetic clades or species of megafauna. Now, the prevailing interpretation in the recent literature is that of a co-causation of human exploitation and climate environmental modification. In general, it's more than evident that the balance leans toward the one of the other of these factors, the humans or the climate, depending on the different taxa, epochs, and above all, the various regions considered. For instance, there is a huge difference between continental situation and the insular situation. Anyway, it's impossible to deny that in many cases, exploitation and habitat transformation by expanding human population was a really important, if not the major, proximate cause for the extinction of large animal species in this framework of time. Within the models of fauna extinction due to this joint effect of climate change and human exploitation, there is also room for speculating on the cascading consequence that the disappearance of key species of fauna may have had on the structure of animal and vegetational communities, at least at the regional model. An example of this is this paper of Jacqueline Gill, which has produced a lot on this topic. Very nice paper. In this paper of 2014, Jacqueline Gill tells that these extinctions, those of megafauna between 50 and 10,000 years ago, were time transgressive, size and taxonomically selective, and were caused by climate change, human hunting, or both, so in line with the compromise of the coaction. And she continues, a growing number of studies support the hypothesis that the loss of the Pleistocene megafauna resulted in cascading effect on plant community composition, vegetation structure, and ecosystem function, including increased fire activity, novel communities, and shift in biomes. Holocene biota thus exist, and this is the final sentence of this paper, outside the broader evolutionary context of the Cenozoic, and the late Quaternary extinctions represent a regime shift for surviving plant and animal species. The general model offered by Jacqueline Gill and others is one of the complex interactions between climate, humans, megafauna, fire, and vegetation. These models need surely further empirical testing from different regions and epochs. Anyway, they suggest that still in the Upper Paleolithic, humans were already in the position of exerting systematic ecological effect of primary importance, at least at a regional scale. But of course, the interaction of humans with terrestrial fauna and plants was not an exclusive affair of the anatomically modern humans of the Upper Pleistocene and Holocene. Other branches of the hominin bush, as the anthropologists tell the affair of human evolution, the hominin bush, and particularly other species of the genus Homo, had engaged complex relationships with different members of the terrestrial communities. Paleontologists involved in the analysis of the hominin evolution believe that the critical turning point was that of the encroachment of the large carnivore guilds by proto-humans. Starting from a condition of herbivore-oriented omnivory, some proto-hominins of the late Pliocene and early Pleistocene evolved a suite of anatomical, functional, and behavioral adaptations leading to carnivore-oriented omnivory. And after a phase of opportunistic, how can say, klepto-scavenging, this is the term which describes what happened at this stage, klepto-scavenging, some populations around 2.5 million years ago reached an ecological position of full predators. And this placed them in a new position in the ecological trophic web, and in a new position with respect to the large carnivores, from prey to competitors, and finally predators of them. And this transition marked the beginning of the properly human evolution, which eventually led to the terminal branches of the genus Homo, including Homo sapiens. And this process, as documented in several different places at the local scale in South Africa. And in 2020, Forby and co-workers produced a synthetic paper collecting a huge amount of documentation from the whole East Africa during a period of 4.2 million years. And in their analysis, they claim for correlation and between the variation, the increase in the volume of brain during the last 4.2 million years on one side, and on the other side, the rate of extinction of large carnivores in the same area. And they conclude, these authors, Soren Forby and colleagues, they conclude as, we find that extinction rates in large carnivores correlate with increased hominin brain size and with vegetation change, but not with precipitation or temperature change. However, we show through spatial analysis of contemporary carnivores in Africa that only hominin causation is plausible for the extinction of carnivores. And conclude, our results suggest that substantial anthropogenic influence on biodiversity started millions of years earlier than currently assumed. Okay, skeptics can argue that association does not mean causation, that all these remain quite conjectural and unusable for drafting precise conclusions on the emergence of the humans as a major ecological factor. However, similar evidence is accumulating. It's difficult to classify all this as a transient scientific fad. But at the end of the story, what is the importance for all these on the topic you are discussing regarding the onset of the Anthropocene? Because this is a different question. I have not answered for this, I'm sorry. But I can only say that the ecosystem engineering is a deep characteristic of the humans. Some very essential tract of their biocultural profile since the early phases of the hominin evolution, or at least from the origin of our genus. This interaction has been, and still sometimes are very creative, but in other cases can be very dangerous and destructive for the environment and the humankind itself. And most importantly, the ecosystem engineering is at the very core of the niche construction process, which makes the human evolution a largely self-organized process in the pre-Gogenian sense. As all process of this kind, the biocultural human evolution is a continuous one, and trying to mark distinct phases and definite transitions within it is a matter of simplification and taxonomization of a complex but definitely coherent, entropically driven history. Nevertheless, a self-organization process, as human evolution is a non-steady progression. Moments of acceleration alternate to stasis. Steady equilibria can be followed by chaotic dynamics, and what is more important, new properties of the system do appear along this complex trajectory. New emerging properties. The farming transition, the industrial revolution, the grid acceleration, the capacity to handle the nuclear energy are all emerging properties of this continuous process fueled by interaction between humans and the environments. I don't know if one of them is more important than the others. Probably it makes no sense trying to establish a priority since all part of a continuous self-organized process began with the appearance of our genus, or even with that of the first hominins. I'm sorry for not having offered any definite suggestion, any practical suggestion for guiding your efforts in identifying some onset of the Anthropocene and its markers. But I had to tell my story, which is what ecology and anthropology honestly can tell. But have a final comment. The moral of this story, the story I told you, is that trying to define for what I know, to define the Anthropocene from a geological, as new a geological epoch, using proper methodology offered by stratigraphy, for instance, is an affair. Analyzing the process of the self-organized evolution of the humans and the evolution of their rapport with the environment is a totally different affair. So, what I want to tell? I want to tell that listening your talk, I remain even more convinced than before that the idea to look at the great acceleration for a real important moment of discontinuity in the geology of the planet is absolutely a good idea, viewed from the outside, from my point of view. And trying to concentrate your attention to setting proper methods and indicators to give a good definition of this transition is okay. Because if you are influenced by other considerations and try to shift backward a little bit the discontinuity to the beginning of the Industrial Revolution, maybe, to the, deforestation of the Bronze Age, maybe, to the onset of Neolithic, maybe, to the onset of the horticulturalism, maybe, but attention, following this line of reasoning, I tell you that you will find yourself looking at the stratigraphy of the Olduvai Valley to find the golden spike for the Anthropocene, which could be not a very good idea. Okay, that's all.
Guido, thank you very much for your very interesting talk. We have, unfortunately, now no time for questions, but later, yes. So please, all questions for Guido Chelazzi this afternoon. Now, I introduce you my colleagues. Marco Benvenuti, which works with me in the Dipartimento di Scienze della Terra, is a sedimentologist, and he is also responsible of our visit to Florence tomorrow. So please, Marco, tell us about the geological footprint of Pisa and Firenze, the flood hazard perspective. And mouse.
Con questa mandi avanti e indietro, e col mouse, se sei fortunato, hai l'indicatore.
Ok, sì.
Thank you, Adele, and hi, everybody, also for those listening online. I promise that I move your attention toward a more local scale and telling about the experience of a field geologist applied to the study of urban environments. So I like to start my presentation talking about science. I would like to, why don't move? Okay. Talking about science fiction, and specifically talking about the Star Wars saga, which led generation of fans like me into a fantastic journey toward incredible planets parsed in the deep space, such as those. We have to wait. Yeah, we have to wait.
Some other
okay. Such as those completely transformed in the whole cities. In my opinion, this fantastic representation brings to the extreme consequences the ability of evolved civilization to completely change the face of entire planets. So I exploit this suggestion for introducing the relation between urban environments and Anthropocene from a geological perspective. Since the early civilization on Earth, villages, towns, cities became larger and larger through times, are the most impressive evidence of how humans can transform the land surface. Even in the geological discussion about Anthropocene, urban landscape are exploited as the more eloquent image of this new epoch in the Earth history. Even if urban settlements may cover a limited portion of the Earth's surface, on the other hand, they determine and are afflicted by most of the emergencies ascribed to the Anthropocene. As claimed by the UN Goals for Sustainable Development, among social, cultural, political, and economic issues, the demand for clean water and energy, the climatic crisis, and increases resilience to be achieved by communities also for the exposure to georisks, make earth science and geology to play a major role in contributing to manage and possibly to solve these problems for the present and future generations. For instance, geologists are able to extract from urban stratigraphy important information concerning the occurrence and the impact of ancient geohazards, such as volcanic explosions, earthquakes, floods, tsunamis, and so on. So, I would like to present two case studies of a site-related urban stratigraphy and geology for Pisa and Firenze, two main Tuscan towns located in the plain of the Arno River, and for this reason, naturally exposed to high hydraulic risks, as documented also in the recent history of the two towns. The first case refers to the amazing Pisa San Rossore Roman shipwreck site located not far from the famous Leaning Tower, where 17 perfectly preserved Roman ships and their cargoes were recovered in the shallow alluvial subsoil of the plain. We had the fortunate chance to study the sedimentary matrix of this incredible archaeological record, integrating stratigraphy, sedimentology, geochronology, and palynology, resulting in the reconstruction of a fluvial harbor the Romans settled exploiting an abandoned meandering channel of the Arno River, still connected to the sea at about 3 kilometers from the Roman Pisa. Stratigraphic and sedimentological data recognize the recurrence at century and decade scales of several catastrophic floods generated from crevassing and overbank flooding from the adjacent active Arno Channel, which periodically invaded the site, bringing a large amount of sediments up to definitive siltation occurring at the end of the Roman age. Catastrophic floods are grouped in 4 main clusters, represented by as many cross-stratified sandy silty units, representing the expansion of sediment lobes in the harbor, floods by floods, fed by crevasse channels. These sediments include entire ships and their sparse cargoes as exceptional and unusual resedimented class. In the picture to the high left, you can see some of the Roman ships during recovering, literally sedimented within the cross strata and oriented transversally to paleo directed to the north-northwest. Palynological analysis revealed the vegetation context of the site and surrounding areas, indicating that the slopes facing the plain were covered by a Mediterranean, warm, temperate forest. Surrounding the site, hygrophilous grasses and plants thrived on a waterlogged and poorly drained soils. The main conclusion coming from pollen data confirms that the Roman age was a warm period following and preceding colder stages. When the chronology of the flood units obtained by radiocarbon and archaeological dating is plotted against the frequency of floods of the Tiber River recorded for the same period in Rome, we can see a quite good fitting, especially for the Republican and the early imperial period, documented a frequent flooding in the two ancient cities, possibly related to common hydroclimatic regime affecting central Italy, and especially the catchments, the river catchments such as those of the Tiber and the Arno. The lesson learned from the modern Pisa is that whatever a weaker or stronger anthropogenic forcing on the climate system, depending on when the Anthropocene started, as discussed in this symposium, warm periods seems apparently related to an high probability of catastrophic floods, such as is recorded today by repeated floods affecting the coastal reaches of the drainage network of Tuscany. Moving to Firenze, this case deals with the pre-urban morphological and hydrographic legacy for the development of the town since its Roman foundation, again stressing the exposure to flood hazards. Floods regulated the history of the town, as demonstrated by the several commemorative plates of historical floods sparsed in the downtown, such as that presented here, referring to the record of a highly destructive 1333 flood event. Extracting information about the surface geological processes in densely urbanized areas, such as that of Firenze, is not a simple task for field geologists like me. Digital topographic models may help allowing the recognition of features hidden by the urban structure. Considering the basic topography of the plain, and in particular the contour lines distribution, we can observe plant forms related to the ancient progradation of alluvial fans in the plain, such as that fed by the Arno River, entering the basin from a narrow valley upstream, or those of its tributaries, such as the Mugnone and Terzole Creek. Focusing on the trend of the 50-meter contour lines, we can observe further interesting features, such as a limited elevated surface resting above 50 meters where the Romans settled the first town, protected by floods from the adjacent Arno channels. And tracing the same line, you can observe former alluvial valleys such as that of the Mugnone Creek and river confluences such as that of Africo and Arno rivers, the latter located north of the present position in prehistorical times. The hypothesis of a northern course of the Arno River seems supported also by independent data coming from recently published results of the seismic microzonation of Firenze. This map shows the seismic amplification modeled for an earthquake at a given frequency for Firenze, with the color range indicating with the blue weaker amplification of the soil and red stronger amplification. This is also the proxy of the thickness of the soft sediment cover resting above the hard bedrock of the basin, being thicker in the blue area and thinner in the red one. But what is important to observe is these linear features, west-northwest, east-southeast trending, which is interpreted as a former valley of the Arno, incised in basin fill, and quite well fitting, why don't, oh, it's blocked, stop. Yeah. I don't know if you can. It's a pity because. Ah, sì? If you can. Anyway, there is an overlap with the northern course of the Arno, fitting quite well the location of these paleo valleys detected by. Okay, yeah. So you can move the slide, please. The next one, yeah. So the next. So restoring restoring geomorphological evolution of the plain, starting since an advanced middle Pleistocene, we can see alluvial fan progradation in the basin, next followed by river channel entrenchment, and definitely following the next slide, a southward shifting of the channel network reaching the present position already established during the Roman settlement of the town. Okay, the next. So we focus here on this last stage in the drainage evolution with the migration to the south of the confluence of the Africa and Arno channel, creating a confluence pool as normally formed when two streams converge due to an enhancement and amplification turbulent jet and also for the morphological feature of the confluence itself. Prossima, next. This feature, inherited by the hydrographic evolution, well explains why, during exceptional floods, such as that of the November 4, 1966, the Santa Croce neighbor experiences the highest water level reached during the event, about 3-4 meters on the ground. That's why Santa Croce is founded just on an existing confluence pool of the Arno-Africa channel. The next. So, the story, the relation of Firenze with water is not only a matter of flood hazards, but also a good example of adaptation and mitigation from the local communities of the hydraulic risk. For instance, by the progressive deviation of the Mognone creeks during the enlargement of the town since the Roman age. Prossima, next. Arno River represented also a source of opportunities for the flourishment of the town, especially during the Renaissance. In this classic Pianta della Catena, showing a seaside on Firenze and the Arno looking from southwest, you can recognize several features demonstrating a positive relation between the town and the river. Prossima, next. You can recognize the Lungarni, built also as defensive protection against overflow. The pescaie, which are transverse structure, creating conditions for water captation. Several mills distributed along the course, exploiting the water energy for industrial production of goods. Different types of resources related to the river, such as raw material, sand and gravel for construction, fishes for food. A suitable way for transport. So, concluding, I'm going to conclude. Okay. So I am convinced, and maybe also you, that urban environments represent the stronger evidence of the anthropic capacity to transform the planet. Besides their dimensions, okay? Urban geology, in my opinion, and geoarchaeology, as I tried to demonstrate, are suitable tools for assessing the space-time relation between physical processes shaping the Earth and the mankind throughout its evolution. As a personal opinion, I think that the geological community should pay attention not only to define when the Anthropocene started, this is a very interesting discussion, but should use the anthropogenic discussion also for promoting the concept that geology is transforming in the science of exploitation into the science for a sustainable living of everybody on this planet. So I think that the effort of the geological community on this topic will be important in the next future. Thank you.
Thank you very much, Marco. Very interesting presentation, but you forgot one information. And
Okay.
But I think that probably there will be a lot of questions for Marco. So also as for Guido, all question later.
I want to remember.
But please,
I want to remember that tomorrow morning, starting from 9. With the meeting point here in front of the department, we will move to trace this part of this story that I tell. And so, you are welcome if you want to join this trip.
Divide l'iscrizione in...
What?
Si devono iscrivere.
Okay, you have to...
To the desk. To the desk is important if you like to be with us in the excursion to inform Gabriele for your participation.
Okay.
Okay. And so we have the lunch break now, but please to be here at a good time for the first presentation of the evening, which is Early Transformation by Earl Ellis. Okay? Thank you for your participation and see you later.
You don't need. Oh, yeah.
Those descriptions have changed from the years back. I have no experience about walking around the city at all. So it's going to be interesting tomorrow.
Pre-industrial changes in climate thousands of years ago that began through this early agricultural transformation. But I'm going to talk more about biodiversity. The idea that the biodiversity of this planet represents the most consequential of human transformations so far. Now, climate change is accelerating and will ultimately probably become the most transformative effect even on biodiversity. But the past effects have mostly been through early human use of land for agriculture and even before agriculture. And this basically drives us away from this classic idea of the natural biome shaped by climate to understand the biosphere as shaped through human use and populations in many different ways, to create a whole nother way of looking at the shape of the biosphere. These changes have a long, long history. They begin very early, even before the Holocene, and we talked about the contributions to megafauna extinctions, but it's not the only ones, and they scale up over time as societies scale up and through the increasing use of energy by human societies. Okay, so these are not moving super fast. This is a long-term process, thousands of years, a geologic process, not a very quick, rapid one. And what I've shown there is a mass oversimplification. What we really have with the changes in the human world is something very similar to what we've seen in the long-term changes in the biological world. They're evolutionary changes and they are full of diversity. They do not all occur at once, and to understand the biology that we have today, we have to understand this long history. And it begins as early as human use of fire, which is an unprecedented capacity for any species. The use and control of fire, including this example here of the use of fire to transform and manage vegetation in ways that sustain those societies. So the idea that the first transformative land use of humans was agricultural is incorrect. Hunter-gatherer societies began doing many of these things, like burning the landscape to improve their success in hunting and foraging, but also learning how to use many more species and changing the ecology of those species, learning to process and then propagate different species. That propagation also altered the evolution of many species on Earth, especially plants, but also many animals, and then ultimately put this on the road to agriculture. But long before agriculture, there's already evidence across many, many species. This is part of a much bigger table describing how human interactions with different species has transformed their evolution, in this case with response to just particular traits. But this list is just a tiny fraction. Humans have been transforming the evolution of species for thousands and thousands of years. Now, as agriculture is not just agriculture, agriculture has also been changing over thousands of years and becoming more and more intense, as we know. And those different changes have big effects on why it's possible for a smaller number of people in the past to have a larger consequence for the biosphere and the atmosphere through their agricultural practices, because earlier land users use more land per person than contemporary ones do, because they don't have to use the land more efficiently. There's plenty of land, so they begin using it in these relatively low impact ways, and the impact just increases and intensifies. And recently, using models, this is the latest Earth system model for global changes in land, and we can see that over the last 12,000 years, we have human transformation that is going on relatively slowly. There is some acceleration that you see in the 1800s, not in the 1950s. In fact, if you look at the 1950s, you may see here, there's a little bit of a slowing down going on here after 1950 in the transformation. It's also worth noting that at this time, we have more than 3/4, this is 12,000 years ago, we have more than 3/4 of the terrestrial biosphere is inhabited and used in some way by human societies. There are a huge number of projects that are emerging to study these patterns of change deep in Earth history. And we've worked with a few of them. One recent effort that I was largely in charge of was a study that brought together the knowledge of archaeologists across the planet to basically categorize the levels of transformation through agriculture of the different regions of the world. And from this, we learned both that, of course, the trajectories of change differ in different parts of the world. This shouldn't surprise anyone. There's not a simple Earth transformation that's all recognizable globally, although we could look at it that way. That's something that we'll see later. But of course, the pathways of transformation differ tremendously in different regions of the world. And there's many different origins, as we know, for agriculture, and the pathways that they take toward transforming their ecosystems are also different. But when we boil it all down to a global trajectory, it's not hard to see that thousands of years ago, we are seeing agriculture essentially transform the planet thousands of years ago. We also see that that model that I showed just now is actually less impactful than the archaeological knowledge would imply. If we look at this chart, it's just showing how many regions, and you can see the orange colors over here. These were underestimated how early agricultural transformations occurred in the regions. So there's even a deeper history of agriculture, a broader history of agriculture than even any earth science model has truly taken into effect. The evidence base for understanding early transformations of Earth is expanding rapidly according to new technologies. And one of those has been the ability to look under forests, especially forests like the tropical rainforests that have often seemed to many to be these kinds of pristine areas, in fact, are regrown, they're regenerated after thousands of years or hundreds of years of recovery since a society of the past may have collapsed or lost its population. And just as one example, I believe from Belize, but these things are found all over the place. Another classic example is Angkor Wat. So underneath these forests is a deeper history. And we really do need to understand that deeper history if we are going to understand human transformation of the planet. This is expanding across the world. The idea that we could actually look at the surface features of the entire planet using high-resolution, three-dimensional systems like LiDAR are increasingly becoming a possibility. And when we do this, we see the features and the fingerprints of the human world impressed upon the planet. Archaeologists are increasingly interested in not just looking at a particular time, but going across the entirety of time, all the way up to the present. This has not been the tradition of archaeology, or at least most archaeologists, to look, for example, after the 1950s, to look at a continuum of human environmental change. They tended to work more into the past, but the techniques are evolving and getting better for looking at the continuum of human-caused anthropogenic transformation of the planet. So what is the utility of limiting the evidence to be considered and understood as human transformation of the planet in the Anthropocene? What is the purpose of narrowing it down to this narrow window of the 1950s Anthropocene? And I think we need to question why we would hold back evidence of earlier human transformations. The Crawford Lake history is very illustrative, with the Iroquoian here showing very strong evidence of human transformation of environment, yet this is basically erased from the Anthropocene by a 1950s limit on where we're going to look for the evidence of human transformation of Earth. This is a little like the streetlight effect. The streetlight effect is from the classic joke. You come across a man who is searching on the ground for something they have lost. And you ask them, so what are you looking for? And they say, I lost my glasses. And so you say, well, where did you lose them? And they said, well, I'm not sure, but I'm looking here because this is where the light is. Selecting this kind of limited observational field is not going to succeed in understanding human transformation of the planet. Anthropogenic change, human transformation of the planet, the Anthropocene, is a time-transgressive, highly dynamic, ongoing, and heterogeneous transformation. It is not understandable through single indicators at single sites. It is a hugely complicated process that should not be understood as having a single time boundary. And if we look at some of the evidence recently put in place or portrayed here in Head et al., we can see that, well, a lot of the indicators here show earlier increases than you would expect if you were trying to mark the beginning of something. The beginning of this, say, cropland and pasture land, the use of the planet, the most extensive use of the planet, begins thousands of years ago. Why would you mark it at a time like the 1950s where it has basically stopped expanding at all? And the most important question when we look at this big picture is also, what does this mean for the current time? What does this mean for the future of understanding this human transformation? And as I said, things have not stopped changing in the Anthropocene. If we look here, we can see some projected trends for human populations where we're seeing a great deceleration of human population growth. That is what is going on in this time, not an acceleration. The same is true of the landscape use of human societies. It has leveled off. It has leveled off since the 1990s or so, and it began this process really in the 1970s. And so the idea of a great acceleration in all matters pertaining to human transformation of the planet is not correct and misleading, in my view. So we must look at these earlier transformations if we want to understand the human world and its transformation of the planet. Thank you. All right, I think I have time for a question or two. Am I correct?
Yes, thank you, El. I think we have time for some questions. Does anyone have a question here? Sorry, Francine, have you got your hand up?
Thank you, Earl. That was a really beautifully illustrated talk. I don't disagree with almost anything of what you said, but I don't see the relevance to the definition of an epoch of geologic time that means the same thing for everyone. And mine is the Crawford Lake site. And to me, contrary to how you've illustrated it, which you're entirely allowed to illustrate it your way, but to me, the value, one of the great values of the Crawford Lake illustration is that, yes, the biggest single impact on Crawford Lake was in 1268. But that happened in Crawford Lake, whereas when I looked at the record of the 10 or 12 GSSP candidates in the talk I gave with Jan at the IGC, every site we looked at, whether it was a stalactite, an ice core, a coral reef, a lake sediment, peat bog, they all responded around the mid-20th century. And nothing, like there was no global hiccup to the planetary system that happened when 350 Iroquoians were farming corn, beans, and squash in the Crawford Lake Basin, although Crawford Lake's ecosystem, as you can see in that diagram, never went back to pristine conditions. So we can look at the same diagram and get very different things out of it, but to me and to my colleagues in the Anthropocene Working Group, having a time period that means the same thing, that has a common base, is what we're after. We're not saying we are determining the earliest anthropogenic impact on the planet. We're not trying to capture all anthropogenic impact on the planet. We're saying that no matter where you look on the planet, there seems to be a hiccup to the Earth system that has been overwhelmed, and that happens in the mid-20th century. So I'm not really asking a question, I'm just pointing out that we can use the same example. You're talking about anthropogenic impact, and I'm using that same diagram to illustrate how it captures, as do 10 or 11 other sites, a major hiccup in the Earth systems at the same time.
Thank you for that, and I do appreciate what you're saying, but I have to ask the question is, if I chose a group of sites that would not show a 1950 signal, I am confident that I could find them because sites vary a great deal in what signals they capture. The idea that we would ignore this signal, in fact, the 1950s Anthropocene is just that little piece of sediment on top of that huge history of sediment accumulation. Why would we cut that off there and ignore the past? And that is essentially what will happen with a time boundary and a sedimentary boundary or chronostratigraphic boundary set in the 1950s. All that previous understanding, all that previous record becomes part of another thing, not the Anthropocene, not the human transformation of the planet. So it is relevant to this question, but I've actually saved most of the discussion of these kinds of issues for the next presentation, which is on the event versus epoch.
Okay, thank you. I'll pass it on.
Thanks, Earl. Really appreciate you being here and sharing your views on the Anthropocene. I think it's really important to explore the Anthropocene from all kinds of perspectives. So I think we're all really pleased that you're here sharing your thoughts with us. I'll just, of course, there's plenty of time for discussion about the various details here, but let me just give you my personal take on, if you like, your Anthropocene. I think the impacts that you've talked about, the impacts that you've talked about going back over millennia, I think are really important.
It doesn't really matter. I just saw that you were going to Kettle's Yard, but I don't know what to do, really.
Anyway, we seem to have got a bit of interference from somewhere.
I think Phil's got his, oh no, he's muted.
But I guess my point with this anthropogenic episode that you have been referring to, while I think it's perfectly reasonable to legitimize this with a name of some sort, why call it the Anthropocene, which clearly has chronostratigraphic connotations? I don't understand why these two concepts, a chronostratigraphic concept and an anthropogenic episode concept, I cannot understand why they could not coexist. And if they do coexist, then I would welcome that to happen. But then the confusion with having two different concepts sharing the same term would be, for me, a pointless confusion. So why not call your anthropogenic episode by some specific, unique name that would then identify it as being a novel concept worthy of its own unique term?
Oh, your microphone
This
is not
my
on.
terminology. The Iroquoian is a term that is from actually the original research, and it's not mine at all. And I'm just highlighting a history of a place that has been transformed by people that deserve to be recognized as people.
That wasn't the question.
The idea of confusion, I think we'll get into that next. I'd rather take some more questions, because we will talk specifically trying to address your question.
Oh, Earl, I'm sorry. There was a bit of confusion there because you were speaking at the start and there was no noise coming from you.
Not the Iroquoian we're asking about.
It wasn't the Iroquoian that was being asked about. It was about the Anthropocene as terminology.
Yes, and we will talk. Okay, well, we will talk. This is not my Anthropocene. I think the Anthropocene is a little bit beyond me. It's very much beyond this room, and we will talk about it I mean specifically. This talk was not about necessarily talking about the need to use the term Anthropocene. The next talk is, and I think it's 8 o'clock. Do you want to go ahead and just go ahead?
Yeah, we have a couple of questions being raised. Emlyn Costa would like to ask a question. I'm just thinking about timing wise. Can we do, Emlyn, would you like to raise your question now? And then we also have a quick one for Mark Williams as well. So Emlyn, if you could just.
Yeah, thanks, Simon. And I appreciate how you've opened up this dialogue. I would just like to, realizing that this is the beginning of another slice of consideration of the Anthropocene, I wanted just to link back to what Guido Schillaci, I hope I pronounced that correctly, said this morning. I thought when he used the phraseology that the stratigraphic and human views of the Anthropocene are what he called different lines of reasoning, maybe that's just saying what we all know, but I think that tends to pinpoint very valuably that these are two different paradigms of philosophy, and so from each of their reasoning contexts, they probably can be argued to have the respective validity. I think the way to approach this, and the way I'm approaching it, and how I wrote recently in episodes, is from a public perspective. The geologists are served by the geological timescale, and that leads us to GSSPs and to stratigraphic rationalization of the Anthropocene, and maybe or maybe not the mid-20th century, whatever. But what I think is also valid in this discussion, and maybe from my perspective, more significant, more salient from a Earth system, Homo sapiens screwing up the Earth system point of view, is the long view that we have to, I think, recognize is sorely lacking in the psyche of Homo sapiens today. Most people have no idea that human life evolved from wildlife hundreds of thousands of years ago, and that has been progressively, as Earl has said, without repeating his words, progressively and continuously and for unknown durations, continuing to modify and alter what nature left before Homo sapiens started to evolve. So I feel that it's not an or. It's what are we actually trying to do and for what reason? And I again resort to the power of the concept that these are fundamentally different lines of reasoning. And for me, the more important line of reasoning is the one that will help humanity to do a slightly better job at managing what it's inherited in terms of the planet.
All right, thank you, Emlyn. I'm going to take that as a comment and ask Mark for the question.
Yeah, I was about to say the same. So, Mark, could you, if you have a comment, could you make that now, and then we'll move on to Phil Gibbard in a second. Thank you.
And just to note, I gave that talk on transformations to talk just about early human transformations. It wasn't specifically about the Anthropocene.
Thank you, Earl. Mark, are you there?
Yes, I'm here, Simon. Hello, Earl. Earl, if I may, I mean, I enjoyed and appreciated much of what you presented in your talk, and there's a fantastic data set that's been assembled there, and you and I have had lots of conversations over many years about this, but I didn't really like the slide that you used of the streetlight effect, the idea that some of us are being selective or narrow-minded or myopic in the way in which we are assessing the data. And I just wanted to speak from my own personal perspective as a paleontologist. And like many paleontologists, Colin Waters, Jan Zalazevich, many others in the room, I've looked at geological history over hundreds of millions of years, at least 500 million years of it. And when I come to assess geological successions, when I come to think about trying to define boundaries, and those boundaries are integral to geologists, to understanding, to providing a framework to an understanding of the Earth system over huge time frames, we'd have complete chaos if we didn't have that kind of structure. I draw upon my whole expertise, and colleagues draw on their whole expertise in terms of defining a geological boundary. And again, I'm not trying to self-promote, but we've recently tried to do a paleontological assessment of where we might define a geological boundary on the basis of human impacts on the Earth system. And yes, we can find clear paleontological signals of impacts of humans on the Earth system, on paleontology, going back tens of thousands of years, as you've said. But none of them will define an isochronous surface until you get to the 20th century. And when you get to the 20th century, you can define a high degree of synchronicity based on the fossil record of introduced species around this planet. And it works very well in terms of the Anthropocene, and it doesn't negate any of the information or studies in deep time which show how we've arrived at this fundamental change to the biosphere. But it is a really useful, pragmatic way of defining a boundary, which then allows us to understand and appreciate how all of those changes have taken place and how we've arrived at the present. So I needed to make that point because
Mark,
doesn't count.
So my presentation was not directed at any specific individual. It was based on the concept of what will happen when the Anthropocene is defined as a chronostratigraphic sequence. It will only include what is after the boundary. That is a fact. And I've actually always been amazed, Mark, given that you do have this much deeper understanding of this long and complex history of evolutionary changes in the biosphere caused by people, why you would find it useful to somehow only restrict the Anthropocene as this very limited part of the history. The utility of that just actually escapes me completely. But if you don't mind, let me just go ahead and give this part of the talk that I was asked to give on the Anthropocene event. And I'm just going to start with this term or this statement by Paul Crutzen. I believe he probably wrote this part of it. It was obviously a contribution from two scientists, one of whom was an ecologist, Eugene Stormer, who actually, in fact, was one of the people who did some of the original work at Crawford Lake, and probably even started talking about the Anthropocene around that work, is the idea that there's no need to assign a specific date to the onset of the Anthropocene, and to do so is simply arbitrary. All right, let me go to my main points here. And I want to make it clear, this is a presentation that is based on work put together by multiple people and really initiated with some ideas by Phil Gibbard about using the concept of an event rather than an epoch to represent the concept and the science of the Anthropocene, this new human age. And let me just say that, of course, the Anthropocene already is defined. I'll talk about a couple existing definitions. And it is defined by anthropogenic change. That is how it is defined. It is defined in no other way unless there becomes an epoch later. The evidence of the Anthropocene is very clear. It is time transgressive. It is dynamic. It is ongoing. This is an event that has not stopped, and it is not a simple, single time boundary event. The general utility, why do we have this term, the Anthropocene? Why is it popular? Why is it used so universally? Because it is most useful in communicating across disciplines. The Anthropocene as an epoch will, beginning in 1950, will limit that utility that it's had so far. So where does this term come from, right? I think all of us are familiar with the fact that this was originally an utterance in a scientific meeting by Paul Crutzen that became a concept. And the original definitions are something like this one. This was the first publication. The global effects of human activities which have become clearly noticeable. That is the original definition of the Anthropocene. In my view, it has never become any better than that or any more useful. It is absolutely useful as that concept. It is in the dictionary, it is defined in the dictionary. In the dictionary, it is defined as the current time or period. Notice the use of the term period. The dictionary is not concerned with epochs and periods as being different, during which human activity is the dominant influence on climate and the environment. Okay, so it does include a little more specificity about these changes, but otherwise it's talking about an interval. It's not really concerned with a time in particular. What we're really talking about here is a time in which human societies as human systems become important and noticeable and even dominant to some degree in the functioning of the Earth system. If you want to understand the evolution of species in the Anthropocene, you need to understand what human societies are doing with the species. If you don't understand this, you cannot know anything about the future. And of course, the same is true of climate change. In the Anthropocene, essentially, human social change is what drives Earth system change. Or, to paraphrase another member of the Anthropocene Working Group, Scott Wing, for me, the Anthropocene means let's recognize that we have permanently deflected the course of evolution. Right? That's a good way of looking at the Anthropocene, I think. So we can look at the Anthropocene through a narrow lens, as everything begins in 1950. But to do so, we have to chop off and eliminate all of that prior information. From now on, if the epoch is defined, it will not include, the Anthropocene will not include a lot of different things that began hundreds to thousands of years before. If you are an expert in the Anthropocene, you will be an expert only in post-1950 changes. And it's not hard to look to see that 1950 does not define the start of many of these changes. It's actually very late. Let's look at alien species. Look at that one. It begins hundreds of years ago, not 50 to 70 years ago. So many of these transformations are much earlier and much more complex. And these are global views. Around the world, we see much more. Oh, you're not seeing the slides. Sorry about that. Darn it. Should have known something was wrong. All right, I'm just going to quickly go through the slides. This was the slide that was supposed to start it. Can you see it now? Can you verify that you are seeing the slides?
Yeah, we can see the slides. Thank you.
Sorry. This was my first slide. It'll come up again.
Yes, yes.
These are the definition slides. This was the Earth system slide. This is that slide. This is the one from Scott Wing's quote. This is two slides that you've seen before because they define the heterogeneity and time transgressive dynamic and ongoing nature of the changes we're talking about. So events. Events are of all kinds. It is true. The event definition is a very open definition. It could be a very small thing in time and space. It can be a very large thing in time and space. A classic example, an example that's familiar to a lot of people, is the Great Oxidation Event. Okay, this is obviously a huge event. It changes the planet more than just about anything that has ever happened. And it is not recognized with a simple boundary because it's not useful to do so. It is a time transgressive and dynamic event that changes the planet. This is a good example of an event that is relevant to understanding the concept of events like the Anthropocene. There's been some talk, some publications that make a lot of difference, a lot of ideas about the idea that events and episodes are not the same thing. Yeah, a little bit, but there's a reason why all that discussion gets really complicated and hard to understand. It's because basically it's a distinction without a difference. We all basically know what an event is. We all basically know that an episode is an event as well. They're both synonyms of each other. They may have some technical definitions in certain publications. Lucy Edwards will be talking about this to some degree, but for the most part, there's no real useful distinction between episodes and events with respect to the concept of the Anthropocene. The Anthropocene is an event. I heard somebody earlier call it an episode. It's really kind of irrelevant. What is relevant is the idea that an epoch would require that there is a before and after step change in time and understanding of the way that the Earth is functioning to a before Anthropocene and an after Anthropocene. That is certainly how people outside of the sciences, and even people who are outside of just geology or even outside stratigraphy, most people will see it this way. This idea that there is a divide, a break between the pre-Anthropocene, not significant human transformation, and the Anthropocene, when suddenly we have a globally significant change. But it's really not relevant to the most important changes that we're making. These are continuous, heterogeneous, dynamic, time-transgressive changes. The 1950s Anthropocene doesn't add any scientific utility to understanding human-caused global environmental change, which was the whole purpose of the concept. It has been recognized, and this is a quote from Waters et al., that formalization is a little bit different for the Anthropocene because the Anthropocene is not just a geologic concept. It won't remain among geologists. It will not remain among stratigraphers. This is a concept that is very, very widely used. So it is important to consider the utility of the concept broadly, not simply as the possibility that a technical group could define a boundary using the techniques of their group, but rather how the official scientific definition serves the public and the sciences, and that includes the social sciences. An Anthropocene epoch will be defined something like this. This is what the definition will look like if it is formalized, at least as far as how it would be treated by definitions. Okay, would this formal definition increase the utility of the concept and term Anthropocene? And I think it's certainly no, is the answer to that. It is already highly useful. You can already see that people are finding it highly useful. Producing a version of this definition with a precise, discrete time boundary, rather than talking about this time of where a process is happening, would be less useful. The vague extended boundary is useful for the sciences. Not only that, is that the term is already in use in scientific articles all over the scientific world. To define it as beginning in 1950 would require it being redefined. It is a redefinition of what is already used differently. Would any formal scientific definition increase the utility of the Anthropocene? I think that's debatable. I think it's debatable whether you really get any increase by having a so-called formal scientific definition. Clearly, using the lowercase Anthropocene doesn't do the trick. You're not even going to be allowed to do that, right? It's going to be capitalized no matter what. A Paleo-Anthropocene concept is really also not really in use and too confusing. The Anthropocene event could potentially serve as this kind of broader definition, although the good thing about it is it's not actually necessary because it simply describes the concept geologically that everyone's already using. That is the common usage of the concept of the Anthropocene, is this idea that human societies, it's a time in which human societies are transforming the Earth system and influencing biodiversity, and that there's a geologic record being formed of that transformation. To assign a more specific date to this is unnecessary and arbitrary. Even with a lot of data, it's still arbitrary. So these are my three main points again. Anthropocene is defined by anthropogenic change. That's it. That's really useful. We don't need an epoch. The epoch will make it less clear what is being talked about. What does it mean to say that anthropogenic change is from 1950 onward? Right? That's going to change the definition of the Anthropocene. It's time transgressive, dynamic, and ongoing. I've said that a million times. And that it's most useful as a term that is used across discipline. And the event basically captures that framing. It doesn't matter whether people say it's the Anthropocene event or not, but the basic concept involved is the concept that is widely used, widely accepted, and extremely important to collaborative scientific work across disciplines in the natural and social sciences across the academic world. Now, I have a couple more slides. Those are my slides. I have a couple more. I'm just going to throw them out here. They're from Phil Gibbard, who is talking more about the issue of, okay, what if we don't use epoch? And this is more for stratigraphers. I'm not going to claim any, being a stratigrapher, I know something about it. That's about as far as I would go. So there are a variety of reasons not to characterize the Anthropocene as a series or epoch. And I can refer back to these slides if anyone has questions about it from that point of view. Okay, and there are also some slides from Lucy that are about the definition of stratigraphic events or event stratigraphy. If we would like to go into that, if questions about that, we can do that with these slides. But I think at this point, the idea is probably not to take questions from me, but rather to have the next speaker, and then there'll be questions of both of us. Is that correct?
That's correct. Thank you, Earl, for that. We will now be moving across to Colin Waters.
Okay, so thank you very much. Ooh, moving around. Actually, I'll go to the first slide. And this gives us a context for my presentation. I mentioned yesterday about this Geological Society of London special publication where we had very useful contributions from Stan Finney. There was also a paper by Phil Gibbard and Mike Walker. And in the abstract of that paper, it has this quotation. Adoption of the term Anthropocene will ultimately depend on recognition of a global event horizon. Without this, there is no justification for decoupling the Anthropocene from the Holocene. So that's the context of this presentation. So first of all, this is something that Earl has discussed and perhaps to a degree washed over in that saying that we do actually have quite a distinctive definition of an event versus an episode. The international guidance from Salvador in 1994 says that an event in geology expresses a happening, not an interval, either of time or of rock strata. It has no formal stratigraphic status and is not one of the hierarchical ranks of units within the ICC. Events do not have formally fixed boundaries. However, major events may constitute a desirable point for boundary stratotypes of stages. Compare that with an episode. An episode in geology is the unit of highest rank and greatest scope in hierarchical classification of diachronic units, providing a means of comparing the spans of time represented by stratigraphic units with diachronous boundaries at different localities. So Earl mentioned some examples of supposed events. Very briefly, I saw the mention of this Great Ordovician biodiversification event, which is something that is mentioned in the Phil Gibbard et al. Paper, but not really discussed in any detail. This is a phenomena which persists throughout the Ordovician, so that's at least 40 million years. Some would argue it extends into the Cambrian by another 10 million years, so 50 million years of very gradual diachronous change. It's represented in this figure by looking at the blue curve, which is the level of genus level diversity trends, which you can see we have increasing diversity throughout the Ordovician, peaking around about the Cambrian, and then a decrease in diversity with time. There's major phases of changes with regard to things like plankton revolution, level bottom communities and reef communities adapting over time. These are all very diachronous events, slow progressive changes. All of these are consistent with an understanding of this as an episode, and many of the discussions at present are really questioning whether it should be called an event, because from the definitions we have, this is not an event. Whether it be the English language or geological language, this is not an event. This is a very slow diachronous episode. But if we start to superimpose the carbon isotope excursions, which is the top curve, we can start to see some interesting additional patterns to add to that of the biological diversity changes. So here we're seeing a number of peaks, some of which are, like the spice one, are quite prolonged, several millions of years. Some of them are very precise, like the Gutenberg isotope carbon excursion. And interestingly, the GICE and the Hernantian isotope excursion as well coincide with chronostratigraphical boundaries. So the base of the Cettian and the base of the Hernantian are at least guided by these significant changes. These are more consistent with what you might want to consider as being an event. Very sudden happenings, which are isochronous to some degree across the planet. Coming a bit closer to present time, looking at the Paleogene, again looking at stable carbon isotopes and oxygen isotopes, you can see general patterns of things like the EECO, which is the early Eocene climatic optimum, is an episode of about 4 million years. You can see there's a gradual change in, say, the oxygen isotopes with time. But superimposed upon that are very much shorter duration events. You know, these are very brief in their extent and very marked as far as the curves that we're seeing here. So we can pick out things like the Oligocene oxygen isotopic maximum cooling events, very short duration. We have the Cretaceous Paleogene impact event is probably the classic example of a very short duration event that transitions the planet into a completely different state in a matter of seconds, if not hours. So that's what we would see as an event, not the slow progressive climatic changes that take millions of years. Now, I want to illustrate one particular phenomena, which is the Paleocene-Eocene thermal maximum. And as you can see from the curves, it represents one of the most dramatic changes to both the stable carbon and stable oxygen isotope curves. And I'll thank Scott Wing for the contribution here. What you see are significant changes across the board during this transition from the Paleocene to the Eocene. If we look at continental markers, there are clear floral changes that happen, changes to vertebrate faunal biota, particularly mammals, also the development of high-energy fluvial deposits. They all start around about the same time, but persist for hundreds of thousands of years. Similarly, if we look at the marine markers, the dinoflagellate Apectodinium has an acme phase that again starts around at the beginning of the Eocene and persists for hundreds of thousands of years. The benthic foraminiferal extinction event is very brief in duration, but again, its start is around about the beginning of the Eocene. And in the marine succession, you also get this very marked development of a clay layer across large areas of the planet. And if you look then at the isotopic evidence, this sudden transition that you see at the beginning of the Eocene is also consistent with a major perturbation of, first of all, the stable carbon isotopes, and also temperature change shown in red, and also a change in the pH in the oceans as well. So if you look at that a sort of general pattern, you can recognize a situation where there's what they call a pre-onset excursion. So there's a period of about 10,000 years before the major change where there is something happening. There's certainly a perturbation. But then there's this very marked onset. So you're getting a marked change both in stable carbon isotopes, in paleotemperature evidence, and then all of these other factors, the start of things like these benthic foraminiferal extinction event, changes across the board. It's that sudden change which represents the event. That happens over about a 3,000 to 5,000 year interval. That's very short duration with regard to geological time. But then we have this phase, which is the excursion event itself of about 100,000 years. So we have, in effect, a plateau. And this is a response which is a sort of stabilizing of the environment after that very rapid change. It takes about 100,000 years or so before we start to get a phase of recovery. So all of that, the CIE we have here, and the recovery phase, is part of an episode of duration of hundreds of thousands of years. But the start of this is very prompt and very marked, and that's the event that we're considering. So we come back into the Quaternary now, and we're sort of aware of these figures where we have Greenland stadials shown in white, the Greenland interstadials, which are broadly equivalent to the DO events, shown in grey, and then there's this sort of interstadial cold sub-events as well, shown in this medium grey. So you could, in theory, say, well, let's take the interstadials as an event, but again, they're relatively long in duration, 1,000 years. They're complex. I mean, you have these little sub-events as well. So maybe what we could be doing here is saying that the onset of these changes, you can see in pretty much all of these examples, the onset of the interstadial is very, very rapid. We have shifts in the curves, both from oxygen isotopes and from the calcium, which is a proxy for dust appearance, is very, very dramatic. And it's that really represents the event. And then we have this period of time which lasts maybe 1,000 years where there's a degree of stability, and then there's a recovery back to the stadial phase. Now, we've sort of seen this figure very, very briefly several times now, particularly in Earl's presentations, but it's never discussed. And yet it's pretty much a critical one. It's a figure that Earl developed in 2016. It was reproduced again in the Gibbard et al. Paper. And again, Emmeline Costa has used the same figure. Now, it's been reproduced in scientific journals. And I have to ask the question, what is the empirical data behind these? Because we have a linear curve showing a gradual change from 50,000 years through to the present day, giving this indication that there's a continuity, a gradual progressive change. There's no significant, sudden, earth-changing event here. And similarly, the lower figures are showing a color change which has no scale to it. We don't know what this means. What is the data that provides the difference between a pale green and a dark green? So what we did within our work is to look at that figure and try and actually put data to it. And I know that Martin gave a presentation earlier on where he showed a simpler version of these figures. But if you take all of those different markers and look at them in detail, yes, you do see gradual, slow changes during the Holocene. So if you take the carbon dioxide and the methane curves, we've discussed these yesterday, yes, there is slow, progressive change until you get to around about 1950 when you can see that significant shift. Similarly, we can look at things like charcoal. Again, we're seeing here actually the opposite, where it's actually a marked decrease happening supposedly in modern times, so that we can question as to whether some of the major paleo fires that we're seeing at present may be reversing this trend. Lead, again, we see an early phase of clear Roman, Phoenician activity, but actually the onset of signal is starting in the late 19th century, but again with a great acceleration occurring in the 1950s. We talked also about species introductions. Early onsets clearly, but significant accelerations in the 1950s. We can go on, keep going on and on. Stable carbon isotopes, spheroidal carbonaceous particles, sea salt, sulfur, nitrates, stable nitrogen oxide, nitrogen isotopes, global sea level changes, sea level changes and global temperature changes, all are showing a degree of consistency throughout the Holocene, a sort of a plateau, and then a step change, which coincides with our 1950s interval. And we can look at even short-term events, radionuclides, organic pesticides, PCBs. Within a decade or two of variation, we have a sudden transition happening around about 1950 In this case, with these ones, we're looking at very short-term events of a few decades, but still clearly aligned to our start of the Anthropocene. So this is a figure that's trying to summarize all these different concepts. And we say that time is the vertical axis, and the horizontal is basically just a sort of schematic regional area with no specific scale to it. But it's just to give you an idea that the late Quaternary extinction is clearly an episode. It's not an event. It's taking the best part of 50,000 years for that megafauna biodiversity change to happen. Then we can look at things like the human transformation of the landscape, particularly things like anthropogenic deposits. And early on, we start to see isolated areas of human development, which with time have become more aggregated into certain areas and more extensive in their area. Within those anthropogenic deposits, we can start to recognize markedly diachronous archaeological ages, so the Neolithic, the Bronze Age, the Iron Age, and even the Industrial Revolution are clearly diachronous phases that are recognized by archaeologists. They have value to archaeologists. But because of that diachronicity, we're not saying, well, you can't recognize the start of the Holocene, the start of the North Grippian, the Megalaean. There's clear events happening, which are short duration, and allow us to provide a time framework to which we understand the variations, the diachronous changes that are happening into human impacts on the planet. It's only really recognizable as diachronous because of these time framework that we have. And then where you argue, well, those anthropogenic impacts on the planet are clearly diachronous, particularly during the Holocene. We would say, well, yes, if there's a use for it, there's a concept here of something called an anthropogenic modification episode, because it's diachronous. It's not a sudden event. It's something that happens slowly with time. But there is an event, and it's what we're calling here the Gaia. And it's the Great Acceleration Event Array. Because as we saw with the Paleogene-Eocene boundary, there's a whole series of events happening, all with different drivers, but all coinciding with the same time. And we're seeing exactly the same thing with the Anthropocene. And that's what makes it really valuable in recognizing these series of events as a marker for a chronostratigraphical boundary. So as we've done with the PEMT, so we're doing with the Anthropocene to say this is a strong argument for this being at epoch level. So just to summarize, events should refer to a phenomena that are brief in duration. This is what gives them stratigraphic significance. Significant events have been used or proposed as guides for the basis of chronostratigraphical units. Episodes are protracted, multifactorial, and typically diachronous intervals, which may contain multiple diachronous phases as well as nested events. The anthropogenic modification episode, the AME, of the least 50,000 years or so of duration, is proposed to encompass all geologically significant changes made by humans to the environment. And at the Great Acceleration Event Array, the GAEA, is recognized clustering around about the mid-20th century and represents the global event horizon that decouples the Anthropocene from the Holocene, as requested in the paper by Gibbard and Walker. So thank you.
Thank you, Colin. So those are, I think we've seen there's some very useful contrasting perspectives we're working with of the Anthropocene, which I hope is of use for SQS members to see this, that it's incredibly well researched by multiple parties to see these changes and the correct, well, it's not not correct perspectives, but the variation of perspectives we have on from different disciplines and from different working parties. So we follow now. I should ask if there's any questions in the room. We could take a question or two now, but we'll be moving on to Lucy Edwards in a minute about arguments against formalization. Is there a question in the room or online we could take now? Or any comments? I see Lucy Edwards just had her hand up there, but maybe that's because she was wondering whether or not she should start. Lucy, are you there?
I am totally there. And no, I thought we had half an hour of discussion before my talk. But Earl had left stuff for me to tell you about episodes because I need to do this. I can share it on my screen or Earl can share it on his. I'll try it on mine. Oh, okay, Earl, share it on yours.
Lucy, yes, we can try if you like.
Oh, okay.
Now, okay, now you, yes, now is good.
Okay.
You got it, Lucy? I can.
Yeah, so Lucy, I'm very sorry, I misread that. I missed the plus 30 minutes discussion, so we don't have to go straight to your discussion there. So your presentation.
I want to go straight. Jeez. I want to go straight to the discussion of episodes because, Colin has taken the International Stratigraphic Guide and quoting the North American Stratigraphic Code. And since I've spent years working on the North American Stratigraphic Commission and helping to write the code, I thought it was really important to make sure that everybody knows what an episode is in the North American Stratigraphic Code. And an episode is a diachronic unit. It's the highest level of a diachronic unit. Colin presented this correctly. But a diachronic unit in the North American Code represents time represented either by a specific lithostratigraphic, allostratigraphic, biostratigraphic, pedostratigraphic unit, or by assemblage of such units. Since there is no Anthropocene lithostratigraphic unit, no Anthropocene biostratigraphic unit, no Anthropocene allostratigraphic unit, no Anthropocene pedostratigraphic unit, it has absolutely nothing to do with an episode in the sense of the North American Stratigraphic Code. And that's all I wanted to say about episodes and the North American Stratigraphic Code.
Can I just come back and you've lost me a little bit here because what you're arguing is to say that there's no stratigraphical expression in lithostratigraphy of the Anthropocene. Obviously, the Anthropocene, as we're proposing, is a chronostratigraphical unit, but clearly there are biostratigraphical features associated with the Anthropocene. There are lithostratigraphical associations with the Anthropocene. So I'm not clear as to why you then say this has no relevance to the Anthropocene. A diachronic unit is a diachronic unit. It is not an event. And to start to say that something that's of a duration of about 50,000 years of gradual change does not fit with anything other than a diachronic unit, in my understanding. So it's an episode. Whether you apply it to now or whether you apply it to 100 million years ago.
What I'm saying is quite clearly a diachronic, formal diachronic unit. A formal diachronic unit requires a formal biostratigraphic, lithostratigraphic, pedostratigraphic, or allostratigraphic referent. You have to name it. You name it the Comanchian Formation. And then you say, you can have the Comanchian diachron. You can name it biostratigraphic unit. You can say the Ojarkadine or Remscheidensis diachron. But you don't just pick them out of thin air and call any diachronic unit an episode. It's just plain formality. It's rules.
And what about with regard to rules for events? Can you just pick out a term such as an Anthropocene event that has 50,000 years of diachronic time to it and say, I'm calling that an event? Where's the formality in
events have no strategy. I love this because, as you know, event is not a part of the stratigraphic code. It's not part of the stratigraphic guide except parenthetically. An event is any scale you want it to be. It can be from a raindrop to 40 million years in the Ordovician. Event simply is something that happened, and it can be any scale. And I know the quaternary people like to say, oh, no, events are very short time scale. But I'm of the conviction that at least for in North America, that the code applies to all ages, not just the one age that I tend to study. So if the Ordovician people call an event something that lasts 40 million years, you can't limit it to being something that lasts only 10,000 years.
There is certainly lots of re-investigation of the usage of term event. The Great Oxygenation Event has been highly criticized by those working on that to say this is not a single event, it's a very complex and diachronous change to the planet. And by calling it an event, it gives this impression it's a simple, single phenomena, and it's not the case. And so they're actually moving towards calling it the Great Oxygenation Episode. And also, at present, the Precambrian is subdivided on the basis of GSSAs, but they're looking at using the very specific true events within that change to potentially recognize a chronostratigraphic unit definition rather than a GSSA. So once you start to recognize things as being very short time intervals of things happening across the planet, then it becomes much more useful to relate that to chronostratigraphy. But if you always call your events something that takes 40, 50 million years to happen, it's very difficult then to use that as a chronostratigraphical tool. So if you look at episodes as being very diachronous changes, they happen, we know they happen across the planet. That's the way things are, but as a tool for recognizing chronostrat boundaries, that's not very useful. Whereas an event, which happens over brief durations of time, is a very strong argument for then defining a chronostrat boundary. Jan and Martin.
Yeah, we have some questions online. Is Jan, are you there to respond?
Yes, I'd just like to pick up on that the fascinating point from Lucy about the episode and the formality of quite how you might define it with respect to humans. And it just recalled, discussion that's taken place now and again about quite how to encompass human impacts and human effects on geology with other kinds of stratigraphy. And certainly one idea that's every now and again is to have if you like, a Homo sapiens biozone, or it could even be an ichnosome, to encompass, all of the physical remains and the effects of our species. That should be, one could suggest that in publication. Would that then make it a possible formal candidate for an episode? According to the North American Code, it would fit. It would be diachronous, of course. It would be verifiable by work in the field.
Sorry, Mary, your microphone's not on.
Lucy. Can't hear you.
Mary, can you hear us? Your microphone wasn't on, Ben. Oh, sorry, Lucy, sorry. I know a Mary Edwards, sorry.
I'm so sorry, I thought it was on. I was going to say, it's a very interesting thought experiment. I personally wouldn't do it, but it's a very interesting thought experiment.
Okay, perhaps worth exploring one day. I mean, we've had the same arguments about, again, lithostratigraphic units, made by humans, and again, those are clearly diachronous and so on. It's just yet another way, of assessing, constraining, describing human-made change, which would be complementary with any potential chronostratigraphic interpretation. But okay, good, thank you for that. I'm glad we can safely pursue the idea of biostratigraphy and humans.
Great, thank you, Jan. A question here, or a comment from Martin Head in the audience here.
Yeah, it seems to me that we're really dealing here with two separate things. We're dealing with, on the one hand, concepts, and on the other hand, terminology. In terms of terminology, well, I guess it is our responsibility to improve the definition of terms so that they serve us better. A good example of this would be the subdivision of the Holocene. Now, the Holocene was informally divided into an early, middle, and a late Holocene. Were these terms, early, middle, and late Holocene, useful? Well, judging from citations, yes, they were extremely useful. But could that utility be improved by a formal definition of those terms? And it was really with that rationale that we went ahead and we defined these terms, early, middle, and late Holocene. And I would say that their utility has been improved simply by defining these terms. It was actually the same with the Quaternary, as Phil Gibbard will remember very well, because we were both very much involved in the issue of the Quaternary. Okay, yeah, so the Quaternary disappeared from the geological timescale in 2004 because it hadn't been formally defined. So we said, well, then let's just define it. And that is, there was a little bit more to it than that, but that is in fact what we did. We defined the Quaternary, and a lot of the problems disappeared because we had defined the term, and then people accepted that definition, and really everyone knew what we meant by the Quaternary, and that was that. I think it's the same with the Anthropocene as a term. Is the term Anthropocene useful? Well, it's been used so much that it would be hard to deny that the term is useful as it stands without any formal definition. But the question again arises, would it be more useful if it were properly or formally or precisely defined? The problem, of course, at the moment is that the Anthropocene means different things to different people, just as the early and middle Holocene meant different things to different people. By defining the term, you actually improve its utility. And then that, in a sense, frees up other opportunities to create new terms for all these other concepts that are swirling around. I think this has some bearing on this discussion of event versus epoch. It seems fairly clear, certainly from a Quaternary perspective, and of course, you know, the Anthropocene is within the Quaternary. Therefore, you know, the way we use the term Quaternary, sorry, the way we use the term event and event and episode in the Quaternary, I think is relevant, very relevant to the Anthropocene issue. So, but if these terms overlap, they're not precisely or clearly, unambiguously defined, well then maybe, and I realize these are terms that are used throughout the geological timescale, maybe this is the time now to start thinking about defining these terms, event and episode, defining them precisely so that we don't end up with these sorts of discussions.
Thank you, Martin. There's another comment here from Francine in the audience. Francine.
Yes, so Earl had asked a question in response to my question earlier, and I wanted to quickly respond to that and then follow up on Martin's comment. First of all, he said, if I found 10 or 12 sites that didn't show something in 1950, would that dissuade you? Or I would argue that I could throw a rock and quite likely hit a site that would hold the record, whereas if you throw the rock, you're not likely to find one that doesn't. So I think on statistical probability, most sites would record a 1950s base. But my response to, and I see Earl will let him chime in a minute, but my response to what Martin just said, which reminded me of something I think that Earl had brought up earlier, the utility of a term, whether having a stratigraphically defined Anthropocene epoch is more useful to waking up society to the screwing up of the planet, given the things that that Colin has documented that have amplified in the 1950s, having a staid conservative body like the International Commission on Stratigraphy, a group of geologists who traditionally have been tarred and feathered with raping and pillaging the planet and so on, to have that group finally say mea culpa, does that not express more wake-up call than, yeah, so over 50,000, over 300,000, we had a presentation earlier that expressed that the farther back you go, you can find human impact, but it's very gradual, but that the Earth has been transformed in so many ways, perhaps not every way, but in so many ways, and that, as I say, a conservative body finally accepts that, I think that's more useful to society.
May I address the comment? That's a very interesting idea that somebody would do some random sampling or systematic sampling to investigate these global change phenomena from a geologic point of view. Of course, this is the norm for other forms of study of Earth system change, although it's very difficult, as you can imagine, and it involves a lot of collaborations, like some of the work we've tried to do. But yeah, I would suggest that is a much better way to look at Earth system processes, to systematically sample rather than choose a few examples that back up the idea that we can find a 1950s record, which was the practice of finding these GSSPs. And I understand that as you go deeper back in time, the evidence of the past is, in a sense, erased over time. It gets remixed, and so it's more and more scarce, and you have to do this kind of cherry picking to find it. That's not the case for the Anthropocene, which is an entirely different type of change process than most of the geologic changes that we are talking about in the geologic time scale. But that set aside, the idea about social utility of the Anthropocene, I think it's already proved itself. Without any formal stratigraphic definition, the Anthropocene is already used in so many ways. It does not need any further chopping off of the tail end of, or the origins of all of things, is going to make it a more powerful message to humanity. I think it simply limits who and what is considered as being relevant to understanding global environmental change. That's all that it would do, because already the term is extremely useful and highly used. I would also say, and this is really, I think, extremely important for everyone to understand, is that the Anthropocene is not, that term is not necessary to recognize that the planet is being transformed by people. You can take that term away, and global climate change, the evidence speaks for itself. It does not need an epoch in the geologic timescale in order for people to take it seriously. It is already being taken seriously because the evidence speaks for itself. The same is true of evidence of moving toward a mass extinction, the idea that we are driving a lot of extinctions. The Anthropocene is not needed as a technical geologic term in order for people to understand how important it is or how much we need to address it. So do not think that by formalizing the Anthropocene as beginning in 1950 as an epoch will somehow be the wake-up call. I think that's an incorrect understanding of how the evidence for global environmental change is already being used, and the term Anthropocene is already being used.
Thank you, Earl. Thank you, Francine. There's another question here in the hall, and then we'll go to Jan, who's online, then Martin. After that,
yeah,
okay?
Stefano, Museum of Natural History, Florence. I haven't heard a comment on the significance of epochs. Epochs, traditionally in the history of our science, are times where there is a new fauna and a new evolutionary fauna. So they need to be long enough to have a new radiation of a new fauna that marks the rocks. And we don't have such a thing now. So whether you discuss about events or episodes, I would like to introduce the discussion about the significance of epochs.
On that basis, would you then say that the Holocene is not an epoch? What is the great biological diversification we're seeing at the start of the Holocene?
Yes, you're right. And in fact, I was not favorable to the introduction of the Holocene, because it's too anthropocentric. I mean, we are looking at the rocks, we are looking at the planet, because we just came last on the planet, and as geologists, we always looked at the big things. I know that probably a big thing is coming next, but we don't have yet the significant stratigraphic interval, a significant thickness, succession of things, of rocks, to document the future change.
Clearly you can't have the rocks which show you the future change because they haven't been deposited yet, but it's, to us, it's not the thickness, it's actually the scale of change that even within tens of centimeters, some of the lacustrine successions we're seeing, it's not the thickness, it's the scale of change.
There's no new species, there's no new fauna, there's no new biota. Something is going to miss, but there's no new introduction, so...
Jan, you've had your hands up there. Can we get your comment or response there?
Yes, if I can. Just a couple of comments and a question to Earl. A comment, well, one in relation to the last one. There are new species from the Anthropocene, morphospecies, if you like. Some of the domesticated animals, the chicken in particular, by far the most common bird on Earth by an order of magnitude or so, is paleontologically, skeletally, quite a different bird from the pre-1950 bird. And you know, it's one example, but it shows the speed at which biology is changing, you know, which Mark Williams also showed in his description of invasives. Just to, again, a couple of years back, I did the equivalent of throwing a rock into a lake, as Francine suggested, and took the textbook of John Small on lake sedimentation, where he had a lot of lake successions. And just out of fun, I Xeroxed the lot of them, every single profile, and looked through them to see if there was an Anthropocene signal, something you could, you know, about 1950, a major change. About 90% of the lakes had such a change to recognize in there. So at least with lakes, you know, I would, you know, in my inexpert amateur way, I'd concur with Francine. But for Earl, my question is, in his very eloquent and indeed address, he was in effect criticizing the whole business of setting up chronostratigraphic units as sharply defined things.
I would just say that I totally agree with Jan that there are plenty of good indicator, not species, but domesticates, variants that could easily be diagnostic around the world, but they do not have any dividing line at 1950.
The chicken does, indeed, I'm afraid. Or a few years later, but 1950 is the key. If you look at the morphological succession of chickens, which a student of Marx and I did, that is a nice example of that. It's clearly a different bird, and I think Mark showed an image of it. But my question to you, Earl, is that do you use the Holocene and the subdivisions of the Holocene in your work? Because everything you said about the Anthropocene could equally apply to the Holocene. And again, the Holocene change is unrolled over 7,000 years or so. So it is a sharp boundary within a much more gradual change. So do you and your colleagues use the Holocene and the Pleistocene and the subdivisions of the Holocene as Martin has just described?
It's an excellent question, and I'll admit that I've actually had to think about this, and I've stopped using the term Holocene for the most part, and just talk about dates and times, because I found that a more useful framework than a boundary set, just having one boundary like that. You can be sure that a lot of people in archaeology and anthropology, etc., do use these terms. Pleistocene, Holocene are commonly used. As for the new subdivisions, I have never encountered anybody who has used them other than in a kind of joke, to be perfectly honest with you. And I've heard generally the idea is that you have to call something the megalion instead of the upper or late really doesn't appeal to anybody. I think perhaps we will see some utility of having actual, real time points attached to upper and lower and this sort of thing might become commonly used. But I think the terminology hasn't been particularly useful to anybody that I know of.
Fascinating.
I'm the expert on all this,
Yeah, no, I'm fascinated by that, because again, it's a clear, case of a different disciplinary perspective. Because for geologists, for quaternary geologists, one could not operate without the Pleistocene and the Holocene, understanding the boundary between them, and moving backwards and forwards above. There is no question at all of cutting off. And that applies, of course, to the Jurassic, the Cretaceous, the Silurian, and all of those. One could take the very same arguments you've applied against the Anthropocene to them. So your comments on the Holocene and its subdivisions, I think, again, they give me a whole new perspective on how...
There is a lot of truth to that. I mean, I find that using the term current interglacial after the last ice age, I find that more useful in communicating to the public who don't know what the term Holocene is. And there's a general feeling, I think, among the sciences, and actually evidence, that people who use highly technical terms that are not understood by even a lot of people in their own field, like Holocene is one of those terms, which is remarkable, but it's true, that using these technical terms reduces the ability of any study to be used by others. So the reuse, the citing, etc., tend to go down when highly technical terms are used, and they are not really necessary in this case. That's not true when you go further back in time. But for the very recent times, I think the Pleistocene, strangely enough, is more well known than the Holocene. All my students in the 100 level class know what the Pleistocene is. None of them know what the Holocene is. A few of them have heard of the Anthropocene.
Well, thank you. That was very, very illuminating.
Thank you, Jan. Thank you, Earl. We're just going over to Martin Head now.
I think the Holocene is probably the most highly cited chronostratigraphic unit, at least in the scientific and social sciences literature, and yet it only represents 10,000 years or 11,700 years. So I would have to disagree with you. But what I also wanted to take up with you was the issue of the Great Acceleration, which actually represents a quantum shift in human impacts on the planet and the planetary response. This is a quantum shift. The problem with an Anthropocene that goes back over millennia, maybe even 50,000 years, is that it diminishes the, if you like, the visibility, or actually it doesn't even acknowledge the importance of the Great Acceleration. And I think I would have to agree with Francine that that formalizing the Anthropocene on the basis of the Great Acceleration, which is essentially what is being proposed, will increase the visibility, will increase the awareness of the general public on the enormous changes that have been made to this planet over the past 70 years. That's not to say at all that the antecedents of this are unimportant. Quite the opposite. I personally find the human impacts on our planet going back over, well, one can go back over millions of years. I think this is absolutely fascinating, and I happen to think that the general public finds this fascinating as well. The kind of work that you, Earl, are doing is fascinating to lots of people outside of your field, and I'm sure to the general public as well. But I think we're being dishonest to the general public if we somehow whitewash over this last 70 years when we have seen these phenomenal changes to our planet caused by this runaway human impact on our planet. Just one final thing. You were talking about a deceleration occurring with respect to human population in the late 20th century, and that somehow this reduced the impact of humans on the planet. Well, I'm not quite sure where you're coming from here, because the fact is, as I said in my lecture this morning, and probably because of the time difference, you didn't get to see or didn't get to listen to my lecture. But I did make it very clear that it was understood when the concept of the Great Acceleration was advanced in 2004, it was made very clear that these rapid rises in growth could not be sustained over the long term. They would have to start slowing. So this was understood right at the very beginning. The fact is that human population growth continues to be positive. That's the crucial thing. Not that it's going up through the ceiling, but it continues to be positive. And therefore, it has a continued impact, huge impact on the planet.
All right, may I respond? Thank you, Martin, for those thoughts. I think, well, I'm just going to put out a term that Stuart Brand introduced a while ago in his concept of the long now, is this concept of nowism. You are trapped at the current time, watching what is happening at the current time, and that everything of relevance kind of expands around the present time, rather than thinking in the big picture, as geologists are famous for being able to do. The Anthropocene is not over. If the Anthropocene were to be defined as beginning in 1950, it has only just barely begun. Okay, so let's just start with that idea, right? The Anthropocene couldn't end soon, could it?
Okay,
so no, let me complete this.
Sorry, I thought it was a question.
The point I'm trying to make here is the idea that the Great Acceleration in the 1950s, that nobody is going to, anyone who looks at the evidence doesn't need the term Anthropocene to describe the fact that in a great many indicators, not all of them, a great many indicators, we do see some accelerations around the 1950s. It's not perfect, but the evidence is clear that there's a lot of acceleration around the 1950s and some really key indicators. No one's denying that. Nobody's whitewashing over that. The evidence speaks for itself. It does not need a small group of geologists to verify it. Okay, that's my first point. So it's not a whitewashing. What would be whitewashed? Not the Great Acceleration. It's already well out there and well known. It's called the Great Acceleration. The data is there. The charts are there. It's well known. It's often talked about with the Anthropocene, and it should be, because it is very relevant to the Anthropocene and human transformation of the planet. What would be whitewashed, what would be removed from discussions of the Anthropocene, which currently is a much broader discussion across a much broader community would be that history leading up. How did we get there? Why did things accelerate? What other changes are in fact deceleration? Like use of land is not in fact accelerating. Human populations are decelerating at the current time. If things go, as you said, in the future, it's not going to be sustained, these patterns that we're talking about. The definition of the Anthropocene in terms of climate change, what if it's possible for human societies to get global climate change under control? Perhaps even push it back so that it is not causing some of these major changes that everyone should be concerned about. What about that possibility? What kind of Anthropocene is that? Defined by the Great Acceleration? Is that the best definition? So I think it's very important to think big picture about the Anthropocene. You could define it in a lot of different ways. It already has been defined in a lot of different ways. But the idea that the 1950s as a boundary between being in the Anthropocene and not being in the Anthropocene is just simply out of purpose. It's out of joint with the way everyone else is using the term and unnecessary. It's already a useful term without any geologic definition. So that would be my main point there. Thank you. Sorry for going on.
That's okay. Thank you very much. I appreciate that. I did actually mention in my lecture this morning that we do have the vantage point of being able to look at very detailed models, quite reliable models that show effectively the effects of the Great Acceleration going forward over tens and hundreds of thousands of years. I mean, it's now believed that the current interglacial at the kind of levels that we're talking about at the moment will be sustained for at least 100,000 years, maybe even 500,000 years. And I would suppose, I mean, obviously one doesn't do geology by looking into the future, but if one were to look into the future, since we are able to do this modeling, I think wherever we are, we'd look back and say, well, the Great Acceleration is where it really started, because that is the point when the Earth's system state left the envelope of Holocene variability. Now, I know you don't really, you're not a great fan of the Holocene either, I suppose, but to those people in geology who do use the Holocene, this is quite significant.
So I think this is an incredibly interesting discussion we're having between various parties. We have a question from Catherine Russell, who's online, a Fulbright scholar recently, I should just always add. So she is going to ask a question. I'll come to you, Catherine, in a minute, but we are running a bit late on time. Yeah, so we had these sorry, Catherine, we had these quite formal discussion times coming up, but we're actually doing it now. So I think we should continue the discussion we're having now up to the coffee break till 3:30, rather than, is that okay with you, Lucy and Jan? And if that's okay, then we'll go over to Catherine to ask a question.
That's okay with Lucy.
I'm sorry, have the coffee break and then have my talk? Is that what you're saying?
Can we do it? We're doing discussions now, carrying on whilst there's good conversation going. If it's okay to have your presentation after coffee break, rather than now.
Yes, that would be perfectly fine.
Okay, we'll keep the momentum going.
Yeah, so it's good to keep this going. So Catherine, nice for you to join us. Could we have your comment or question, please?
Sure thing. Thanks for the introduction. Yeah, so basically, I've just done a 6-month job thing, working on some carbon capture and storage presentation materials, effectively. And what you say about, the end of the Anthropocene and possibly getting carbon under control, I think is a really interesting thought experiment. The reality of that geologically would leave a significant mark on Earth, because we would have to bury the carbon, which over time would mineralize. So we would still end up with perhaps even, deeper than we currently have, in terms of our impact on Earth, very deep and a very permanent new rock type, a record of the Anthropocene. So there's that kind of point as well. And I just also wanted to say that, like, I read history books and like archaeology and that kind of thing. And when I come across technical terms I don't know, I look them up. And I very much find them to be very useful as markers, so then I can refer them over to other studies and that kind of thing. And I find that really, really interesting to do. So I think that naming things is something that humans have always done. We even do it to ourselves. And so I do find those to be really, really useful personally in marking gradations, so that we can understand the scales of change and the position in that change that we exist in. So that's just my personal note. But I was just wondering if you'd considered, I guess, the new minerals of carbon sequestration and the carbonates that would exist because of CCS, if we were to turn this all around.
Thank you, Catherine. Is there any response to that? I think it's true. I think the idea of, like, the Anthropocene disappearing, if we can get climate change under control, it would still, the technology and the energy required to get it under control would still leave a massive mark on the planet. I think it's interesting thought concept. Martin, and then Barbara. Was that? Thank you.
Just quickly, again, I think this was something I mentioned in my talk this morning as well, which, of course, some of you who are in North America perhaps didn't manage to hear. I would suppose that unless we got things terribly wrong, I think it will take quite some time before we can figure out how to suck CO2 out of the atmosphere. But I think that there is a probability that it will happen at some point, by which time I can't imagine that we will be sucking out so much CO2 from the atmosphere that we will be driving ourselves into the next glacial. I think we will, by that time, have managed to get things right so that we are in a constant interglacial, in which case we will have perpetuated this decoupling of planet Earth from orbital forcing. It comes right back to the great acceleration and the concept of a chronostratigraphic Anthropocene with a beginning defined by planetary response and the great acceleration.
Yes, thank you. Barbara Fiukiewicz-Kozioł. I also have comment to Earl, because CO2 is not the only issue of Anthropocene. What about changes on Earth's surface? What about holes made by miners? There are clear evidence of human impact, and these holes are produced now during the last 70 years because of human energy demands.
Absolutely. There's a huge amount of different kinds of evidence, but mining is not starting in the 1950s. And you may see some acceleration of mining after the 1950s. I would believe that, but it's not concurrent with the 1950s. So you'd have to go if you wanted to use mining evidence, stratigraphic evidence of mining, there's much deeper history that would be essentially left behind if the 1950s was, in a sense, the starting point for the Anthropocene. But yeah, that's great evidence, sure.
But you told us about the end of Anthropocene, and what about these holes which are left by human?
Exactly.
How they will be changed.
If that's your indicator of the Anthropocene, then it would not be useful to start the Anthropocene in 1950.
Yeah, but
because the evidence is so much greater across time. So it's not a useful indicator for 1950. But the evidence of human transformation of Earth is super abundant. The idea that we need a special term just to say that humans are transforming the Earth, we don't actually need it because it's so obvious from the evidence itself. However, people have used this term Anthropocene in that way, and that's how it's become a very useful term. It's like a summary for this huge amount of diverse evidence that human transformation of the planet is, that it's transformative, that the whole planet is being transformed. But there are so many different kinds of evidence, and it begins long before the 1950s.
Francine, you have a question?
Yeah, Earl, I'm interested, as I've heard you repeat this phrase 3 or 4 times, that it would erase everything that went before if the Anthropocene were based at 1952 or so. So I know that when the Quaternary was formalized, the Jurassian was moved out of the Pliocene. They lost the Pliocene. I mean, the Pliocene lost the Jurassian, right? But there was nothing lost, right? And it was just simply in a different time zone. So the other day I had a Zoom meeting, and one of our meeting members didn't attend because he miscalculated Central Eastern Time to the time in Minneapolis. So having a time that means the same thing to everyone is important, so people make the same meeting and they're not an hour late. So just because you change the boundary, or you establish a boundary that brings an end to the Holocene and a beginning to the Anthropocene, it's like moving the Jurassian out of the Pliocene. It doesn't take away anything. So I don't understand this, what you mean by, if we establish a geologic epoch called the Anthropocene, that it eradicates all evidence of human impact that ever happened before. I don't follow that. Can you maybe explain what you mean?
Thank you for asking that. But I also have said multiple times that the evidence speaks for itself. And what you're talking about is not the evidence. You're talking about the nomenclature, and how the nomenclature used just by, I'll just be perfectly honest, the Jurassian is a term I've never used, and I don't intend to start, because it is not generally useful for me. It's probably very useful for quaternary stratigraphers, or before. All I can say is that that kind of terminology, if it was just within stratigraphy, yeah, I don't have any concern about losing the Jurassian myself, because it's not a term that I use. The term Anthropocene is an entirely different beast. The term Anthropocene does not originate within geology. The term Anthropocene is used extremely widely by people across many disciplines and well beyond the discipline of geology. The definition that people use is not based on a specific time. It is based on a time, this idea that there is a time in which humans are transforming the Earth. That is what it refers to. And to say that this time in which humans are transforming the Earth must now be restricted, this term, Anthropocene, which refers to this timing of human transformation of the Earth, must now be restricted to after 1950. I promise you, you will see a lot of concern outside of geology, because that is where most people are using the term, about this redefinition of what a term that they'd already been using. So I think it's an entirely different thing to talk about the Jurassian, which is a term used only by specialists in geology, versus this term Anthropocene that is used across the academy and well beyond. So I think it's an entirely different discussion.
When Paul Crutzen apparently got up at this meeting and he said, stop talking about the Holocene. We don't live in the Holocene anymore. We live in the Anthropocene. And he then talked about maybe the steam engine as being the time that we would use. It's very clearly, the etymology is very clearly epochal. And so therefore it means a geologic time. And that's how we're arguing. But anyway, I have had enough time with the microphone.
Can I just make a point as well? I mean, Earl, you repeatedly say everybody uses the concept of the Anthropocene the way you use it, not the way that we as geologists are using, and Earth system scientists as well, because we do relate in how we use this. Now, what's the empirical evidence you have to say that everybody's using it your way. You know, have you done a bibliographic assessment of scientific publications to say clearly the majority of people are using it in your concept of all human impact as opposed to our concept of a mid-20th century major transformation of the planet? Where's your evidence?
Well, I definitely can prove factually that most people aren't using it my way. Yeah, I wrote a book on it, and I can tell you that the Anthropocene is used in many, many different ways. I think everyone in this room, and I'm not in the room actually, can attest to this. If you've looked around, just do a search, and you will find on the internet, and you will find many different forms. In the academic literature, you will find many different usages. And I review papers all the time. I think all of you are familiar, if you review literature outside of geology, that the term is being used in many different ways. That is my point, not that everyone has to use it my way, but I did bring up a couple definitions that are popular and cited highly, like the original definition of Paul Crutzen. That definition, I would say, is currently still the best definition. You've already seen it on this slide. I'm not going to put it back up again. I think that's how most people are using the term. It has nothing to do with me. And then the term as used in the Oxford English Encyclopedia is probably also a commonly used word. They do the research. They do the homework when they do their definitions. It doesn't refer to it actually refers to a period, clearly in that definition. Maybe that needs to be changed to epoch according to what this group is doing. But all I can say is that these definitions are not respect to me. It is respect to this very large group of folks outside geology, in biology, anthropology, all sorts of different disciplines are using the term Anthropocene, and they're not using it to refer to the Great Acceleration. But nobody's denying the Great Acceleration. This idea that the Great Acceleration isn't important, I don't see where that comes from. There's nobody said that. And that wouldn't be a result of not defining the Anthropocene as an epoch in the geologic timescale. The evidence speaks for itself. It doesn't need that.
If you're asking where it's being denied, I showed that figure of yours from 2016 that's been reproduced again by Gibbard et al. From Emily and Costa. That denies the Great Acceleration because it doesn't show it. It shows a linear curve. It shows gradational color changes. So that's where your evidence is trying to deny the Great Acceleration.
Yeah. So it's come to calling me a denier of this evidence. I published a book in that there's a whole chapter on the Great Acceleration. It doesn't deny anything. Mm-hmm. So I reject that definition of being a denier of the Great Acceleration. Nobody is denying the Great Acceleration, least of all me.
Okay,
I resent the implication.
That figure speaks for itself. And I noticed that you didn't dwell on it. You passed through it very quickly.
Okay. Yeah. It doesn't focus on the Great Acceleration. That is correct.
Yeah. Okay, so I've just noticed there's a hand up from Yoshi, one of our SQS members, and I'm just wondering we should go to him now, and then perhaps we should break for coffee, and then we can continue the discussion afterwards. Would that be okay? So Yoshi, are you there?
Yeah. So can I have the slide share?
Would you like to share a slide, Yoshi? Sorry, I didn't quite catch that. Please share a slide if you can hear us.
So I cannot.
You can.
Can you make him share the slide?
Can you share the slide? You have the permission.
Yeah, I need a permission, so I can now.
You have permission to share slides, Yoshi. Okay, so maybe what we should do, can we try and fix this, and then we'll break for coffee now, and then we'll come back straight to you, Yoshi, in looking at the time, in about 15 minutes' time. Would that be okay, Yoshi?
Yeah, okay.
Okay, thank you very much. Thank you everyone for the discussion we've been having. We'll continue. Thank you, Earl. Thank you, everyone. Thank you, Yoshi, for hanging on there. If you, we can see your slide now. So please, if you'd like to go through that, and we're delighted to have your comments. Thank you.
Yeah, thank you very much. So my comments is, so this is a figure of the Asian large rivers. All large rivers, total sediment discharge for the last 5,000 years or something. So 1,000 years ago or 2,000 years ago, by the human activities on the deforestations, sediment discharge increased 4 or 5 times. In particular for the Yellow River, increased 10 times. And for the last 70 years, see another human activities, so sediment discharge decline to the before the pristine levels. So the Ellis mentioned this, so human activities has a long history impacting the natures. So Paul Crutzen is also a geophysicist. Said so left the answer, Holocene enters the new geological epoch. And this meeting, so Martin and Colin show the so many kind of data and great accelerations. For me, most symbolic figure is this one. This is a famous report, IPCC AR6. So right side shows the observed temperatures and also simulated temperature. This is done by the geophysicists. So clearly, both curves depart around the 1950s. So that means before the 20th centuries, all natural systems, our system is simulated, understood by the geophysicists. But we cannot explain after the 1950s without human activities. So now it's a new systems. So this is most important figure for me for the Anthropocene. That's my comments. Thank you very much.
Thank you, Yoshi, for a very well described comment. As I think it is very convincing evidence. We have a question here from Barbara, or a comment.
Oh, well, I have a comment. Yes, coming back to Anthropocene term. Anthropocene is very catchy for society because it includes anthropos. But suffix "scene" belongs to the geology, and geologist has law to describe some alterations, environmental alterations, shifts, etc., using this semantic. And if everybody will use Anthropocene, then it's unscientific use. I hope you agree. And I think it's a philosophical discussion because some of people use Anthropocene as anthropocentric concept, and some use as anthropogenic. We use Anthropocene because we would like to indicate people, anthropos, as an agent of dramatic increase. Okay, thank you.
Thank you, Barbara. Now, we're going to go now to Lucy Edwards, if she's still there, and we're going to do the formal thing on the program where we're going to have an argument against formalization from Lucy, and then for 15 minutes, and then we're going to have arguments in favor of formalization. So it's a heated debate already, So it'd be interesting to see how these two contrast. So Lucy, if you can hear me, and I apologize for calling you Mary earlier.
Oh, yes, I was going to say, give me presentation rights, and you just did. Yeah. No, when people call me by a different name, I just don't answer. So because I don't think it's me, it never occurs to me that it's wrong. Anyway, here's my screen, and share. And I would like to say thank you so much, Simon, Colin, for inviting me. Thank you so much, Adele and Matteo, for helping me to make sure that things go well with WebEx. And yes, I promise to be provocative. Anybody that knows me knows that's not a difficult thing for me to do. So very briefly, here's what I intend to cover as quickly as time allows. And a lot of it we've already covered. As far as I'm concerned, there are two different Anthropocenes, as Earl might say. I want to talk about formalization and geologic time. Colin will love this, the Google hits, more details, and my specific arguments against. Now, when I start talking to undergraduates, what is the Anthropocene? It's a concept to me that humans dominate the environment, or my environment, but the Earth's surface, waters, atmosphere, flora, fauna, perhaps a sedimentary record, and a lot more here. And I just love the slide where one of the socioeconomic trends was the number of McDonald's built. So yes, that's a socioeconomic trend of the Great Acceleration. And humans can be advantageous or disadvantageous. And again, for undergraduates, quite simply, who's driving the bus? Up till a certain point, and we might argue when that point is, natural causes dominated our systems. Plate tectonics, orbital mechanics, gravity, chemistry, and of course, biology. But now, who's driving the bus? Agriculture, hunting, damming, manufacturing, polluting, and are we collectively driving off a cliff? So those are the two different Anthropocenes. Number one, the concept that humans have so profoundly altered the planet that we need to stop, think, and perhaps do something. And I'll call that the Anthropocene call to action. The other concept is the one that is being discussed here, that humans, not the collective we, have so profoundly altered the planet that we're in a new geologic epoch. And parenthetically, that means the Holocene is over, the Quaternary is not, and we're talking about a starting point of 1950, or thereabouts. And as came up in discussion very, very, very obviously, there's a divorce ahead. You've got, on one hand, people talking about the Anthropocene as time, starting at approximately 1950, and the other, the Anthropocene's call to action, that humans are dominating and we got to do something. And right now, they overlap enough, and people use, as we say, we've used the same word to mean different things. Now, my concept of formalization, and I told you I get to be provocative, is to try to fit the Anthropocene call to action concept into a geological time epoch, is trying to put a square peg in a round hole. Got a good set of knives? Big enough hammer? You can do it. But do you want to? So, as most of you know, I go way back with stratigraphic codes and geologic timescales. So let's focus on what is the geologic timescale. And I'm going to emphasize this again and again. Geology and geologic time are about rocks, sediments, and the history that these materials can tell. Materials that you can touch. History of things that happened in the past. Geology is not about the present, because if they're deposits, they formed in the past, even if that was only a few minutes ago or seconds ago. And I'm going to say this, and I've said it before, geology is not about the future. The future is speculative, it's non-tangible. So, again, I get to be provocative. A lot of the criticisms, not necessarily mine, about trying to fit the Anthropocene into the geologic timescale as you're putting the cart before the horse. First, you have the concept, admirably cited by Paul Crutzen, that we are altering the future and we got to do something. Altering the Earth systems and we have to do something. Then you go try to find the rocks that you can that you can do it. And that to me is backwards for geologic time. First you have the geology, then you name the time period. Not first you come up with a concept, decide you want to name it, and go look for the rocks. So I ask you, which of these great acceleration graphs are based on studies of the sedimentary record? Well, socioeconomic trends they may be reflected in the geologic record, but they certainly are not based on the studies of the geologic record. And even when you come to the Earth system trends, most of them are based on historical records. And some of these smooth curves, I don't know where they come from, but if they're that smooth, the data aren't there behind them. And these upper three, of course, are based on ice core records, which are sedimentary records. So Anthropocene, again, the concept is about people. What people have done, what people are doing, and what they may do in the future. And I said this in the EOS paper in 2015. I will repeat it here. There is no geologic record of the future. Once you're talking about the future, you're out of the Anthropocene sensu geologic time. Some of the questions that were brought up in the discussion relatively, well, just before coffee. If you Google Anthropocene, you get 23 million hits. Holocene, I checked it during coffee break, it was only 21. And for comparison, Cenozoic, Mesozoic, Paleozoic, those kinds are, in the 10, 12 million. Now I pulled up my paper from 2015, and there are only 500,000 Anthropocene hits only 7 years ago. You want a great acceleration? That's a great acceleration. Going from 5 million to 23 million. The Anthropocene is here to stay. You're not going to get rid of it. It's so useful as a call to action. It's so useful to get people involved. It's so useful to put a headline. I've seen papers in scientific journals where the Anthropocene is in the title, but nowhere in the paper. And the editors just put it in the title to make it flashy. So my goal was to let's get us all on the same page. Let's not have two Anthropocenes. And, in the divorce analogy, who gets custody of the word? Now, from my perspective, not based on analyzing all 23 million papers, citations, not based on even the 325 Google Scholar citations. That horse has already left the barn. That people are and will continue to use Anthropocene as a call to arms, a call to action, saying we're screwing up our world. So just quickly, how is it being used now? And this is an anecdotal sample. It is not a scientific sample. But this was in Science magazine only a few months ago. And let's see, can you guys see? I hope you can see my cursor, maybe not. Anyway, you see that the axes are not labeled. You'd never get away with that in the USGS because they're labeled as to the units, but not labeled as to what they say. So you notice on the x-axis, it has the past and the future. Not a geological Anthropocene. Just last month, GSA Today. Again, an Anthropocene and the future. So let me just throw in, as I promised, a few details. And I asked Martin this during the question, do you think of the Holocene as the last interglacial in an icehouse world? Or have we left the icehouse world for a greenhouse world? And when you're considering rank, if we are still in the current interglacial, we're still in the Holocene. You could subdivide the Holocene into stages. We already did. But, we're still in the last, quote, interglacial. If humans ensure that the Earth remains in a greenhouse world, and I bet you will. I'm on the exact same page as Martin on this. I bet you that we will not, if humankind survives 100,000 years, we will not go back into a glacial. That the technology will be there and it would be too devastating for humankind. However, if we knew the future, we'd know what was the correct rate. But geology is not about the future. So the rank was chosen simply because Paul Crutzen said a Holocene Anthropocene. And scene, kind of implies epic. But that's no reason to make it an epic. So I think we don't know the rank. We don't know what's the right rank or the wrong rank. Just picking one because we don't want to be too disruptive is a very interesting philosophy. But it's my job to argue against it, so I will. Now I'll see, and I know this will come up again and again, if we don't formalize the Anthropocene as a series and epic, will it make geologists look dumb? Will it make us look like we're denying the significance of anthropogenic change or denying the significance of the Great Acceleration? Will it make us look like we can't make our minds up? Will it make us look like it takes 20 years to put a golden spike anywhere? However, and I'm being polite, if we do make it a formal epic, it'll look like we're taking a word that has been used 23 million times and narrowing its meaning and blurring the significance of anthropogenic change. So, why do I hate the Anthropocene as a formal series and epic? I think it's the wrong rank. I think it's the wrong start time. I think it's the wrong concept to have a single start time. So my arguments against formalization, you can take these down so you can use them in your rebuttal, is we need to move on from putting golden spikes and devising further plans of action. The AWG has done a great job of characterizing it, and we need to take that and use it. But not formalizing it acknowledges that geologists do not own the Anthropocene. It's bigger than us. You can easily display the Anthropocene on a chart, but it's not a formal cell on the chart. And as far as I'm concerned, naming the Anthropocene as a formal geologic epoch is putting a straitjacket on it. And once you can include the future, you are outside of geologic time. Thank you.
Thank you, Lucy. That was, as you promised, provocative and very thought-provoking. There will be lots of questions, I'm sure, and comments. But I'm thinking maybe we should go straight over first to Jan for his arguments in favour of formalisation, and then we can come back and discuss specific aspects of both the for and against. Is that okay? Thank you, Jan, for joining us.
Yes, fine. Yes, I shall just try and overcome my incompetence with all things computerish and try and get to share my screen with you all. There it is, I think. So let me just move it somewhere where I can. Is my screen up there? Yes, can you all hear me?
Hearing you loud and clear.
And can
Jan,
you see the
thank you.
screen?
Yes, we can.
Wonderful, wonderful, great. That's a rare success for me with these things.
Well done.
Thank you, and thank you, Lucy. Also, it's terrifically useful, to have these counter arguments, and they've been useful all along the line to help the AWG sharpen, refine its arguments. It's all been useful, and in a general sense, when a new idea comes out, of course, what one has to do is to put it there and invite everybody to throw bricks at it. And then whatever might be left at the end might be worth something, So I see it very much as part of this process. So I've just got a few slides here, so I shall ramble through them and attempt to perhaps answer some of your points, or at least, try to as we go through. So these arguments, not mine in particular, so I don't own them, but they've developed over the course of the last few years among the Anthropocene Working Group, and indeed with Martin and others, and on the SQS now. Let's take some of these points first. And first, of course, the Anthropocene, as has been abundantly demonstrated, there is really something different going on at a planetary scale, at a geological scale, and at a stratigraphic scale to the kind of conditions, the kind of geology, the kind of stratigraphy that has characterized the last, 11,000 years of the Holocene, and indeed has characterized much of the Quaternary and, in some respects, all of geological time. So it is that differentness that is the object of scrutiny of the Anthropocene Working Group. And of course, it's not all things anthropogenic. It's not all anthropogenic change, as been stated, but it is the response of the Earth system to the impacts, which happen to be human impacts. Again, that is the root cause. But if these impacts are being generated by anything else, by a volcano, by an asteroid, goodness knows what, they would be just as important and just as worthy of attention, and probably rather easier to work with and rather easier to name than the fact of bringing in the baggage of humans and all of that. So again, a diagram you've seen many times, but it's the logo of the Anthropocene Working Group, kindly drawn up by our colleagues at the Max Planck Institute in Mainz a few years ago. And it's based upon, again, one of these graphs. Again, this is big picture stuff. It is atmospheric carbon dioxide, a fundamental part of the Earth's thermostat, and showing the rate of change over 15,000 years across the Pleistocene-Holocene boundary through all of the sub-series, sub-epochs of the Holocene, being more or less horizontal, with showing little or no rates of change. And then very recently, with very large rates of change, it shows also population and methane. But it is this kind of difference and this scale of difference that is being identified. And so at the broadest approximation, the Holocene is horizontal, and the Anthropocene here is vertical on that. So, and it is a descriptive change. It doesn't have any, it is diagnostic. It doesn't, as Lucy intimated, and others have intimated, Earl and others, the AWG is not calling for societal change. It is trying to describe what is going on that is affecting geology, and it's being captured by stratigraphy, and saying that there is something useful here that would be worth naming. It would be worth naming if the word Anthropocene was taken away and used for this rather larger and fuzzier concept. This would still remain, and this would still need a name, because it's big, it's important, it's shaping our world and the world of all living organisms on Earth, and it is worth, it is a geological scale on that. And of course, it's again one of the early questions that we had, including from Lucy, from Stan Finney, from Phil Gibbard and others. Okay, it's an idea, it's a concept, it is Earth processes, but is there stratigraphy? And again, I think the last couple of days have shown that enough stratigraphy has been found, which is both substantial, as shown by Jaya Savitsky yesterday, with these enormous increases in sedimentation. Simply more and thicker strata are being formed, and those more and thicker strata have got very specific signatures. They can be characterized by a body of different stratigraphic proxies, of which a few are shown here. And again, you've seen this diagram before. It's all of the 12 GSSB sites, showing a remarkable correlation between all of them, between land and sea, on that. Something is going on, and that something is producing geology. It is far more clear and distinct than we had imagined. I was, unlucky enough to be caught by Phil Gibbard at in 2009 and asked to set up the Anthropocene Working Group. And at the time, when we began looking at this, it was very unclear whether there would be sufficient change, and whether the change was not just so slow and gradational that it's not worth trying to find a boundary. And simply, as the work progressed, the boundary became progressively sharper and more distinct. So, again, Lucy quite rightly said we're not talking about the future. But I think there is one aspect here, again, it's one that's been mentioned already, about the future that is important with respect to the Anthropocene. And that is, again, that's been noted by Colin, by Martin and others, that they're saying that the Anthropocene is not a blip. The only important thing at this scale, at epoch scale, is that whatever changes ensued, whatever changes might ensue in the future, they will not allow return back to the Holocene, the conditions of the Holocene, or a Holocene-like state. Too much has changed in too many ways. Again, this shows climate, because that's simply the easiest thing to show, the easiest thing to model. Of course, it's a very simplified model, going back 20,000 years and going forward 10,000 years, whether one of those trajectories you take shows no return. It shows a different and warmer Earth, one that will last a long time. And of course, that's one dimension. You know, the biological changes, you know, described by Mark Williams, again, are largely irreversible. The homogenization of the Earth's biota, again, something which, you know, has in very large part been carried out in the last century. That's not an omelette that you can unscramble and go back to Holocene biogeography and therefore Holocene biostratigraphic patterns in the past. So I think that point is important. You know, we happen to be on the cusp of a change which will have long-lasting planetary and stratigraphical repercussions. And again, about the usage, there's been a lot of this discussion about this, saying, and Lucia said that the horse is bolted. But there are quite a few horses out there, and not all of them, by all means, bolted from, again, what is the original definition. The original definition was set up by Paul Crutzen expressly with respect to and in contrast to the conditions of the Holocene. And he was an atmospheric chemist, but he was well aware of that. At the time, he was listening to a presentation of Page's data on essentially stratigraphic data. So that is the meaning, that the Earth, as regards its processes, many of them, and certainly some of the very fundamental ones, like climate and biosphere, has departed from the conditions which were typical of a generally stable Holocene. A Holocene stable, again, if you like, its fundamental planetary support parameters. And again, there are a lot of examples of this. This is one from the IPCC glossary, again saying that humans have changed the planet. Okay, that's part of everybody that, but with a signature that is distinct from those of the Holocene. And there lies its use. It has a specific use, saying that the Earth is now in a different state. That state will obviously evolve, but there's no going back to the kind of conditions in which most of settled civilization developed. And again, the point has been made by Martin and others that formalization is there to help clarity. You know, words are what we mean them to mean. Because we are scientists, we try and be specific, so we can convey information in a very precise way. That doesn't always accord with common language usage, but I think here we do have to try and stay precise. And I think also the public understands that we do try and stay very precise about this. So, again, one of the very useful things about the Anthropocene, it's been picked up by people very widely, I think not just because it's a catchy term and because it's a bit dramatic, but it also does several useful things. One is it takes the recent historical observational record, and by combining that with the stratigraphic record, one can then rather more easily make comparisons with the deep past when things also happened to the planet in in significant ways, which we now find useful as possible analogues for the kind of states that the planet might be moving towards right now. And here again is a diagram drawn up again by Mark Williams, and also again shown that this is a simple boundary. It's part of a time framework. One looks and examines both above and below. There is no sense of truncation of anything. It's simply a rung in a time framework. And the kind of comparisons you can make with the Anthropocene are exactly those you can make in the early Paleozoic here with parts of the Silurian, with the Paleocene-Eocene boundaries being shown, and in others. And in terms of the cart against the horse, I'm not quite sure about this. Quite a number of units of the geological timescale have been and are being first considered as concepts. For instance, currently, there is the cryogenian. That is currently a concept. It doesn't yet have a GSSP at the bottom. The GSSP is being looked for in rocks on the basis of that concept. And the same thing is happening for the Archean Proterozoic boundary and others. So I think that particular sequence of events is rather more involved than Lucy indicated. The other useful thing about the Anthropocene is that it is powerfully integrative, and it does this in two ways. Firstly, it takes a whole set of phenomena which are very often described separately. So when you read news reports about the climate change, or about biodiversity change, or about pollution, or about different kinds of landscape change and the building of megacities here and there, the data from all of those, the description of all of those, the characterization, can be put together in the way that stratigraphy so beautifully does these things. And of course, stratigraphy, is used to doing this for all kinds of things in the deep past. And this kind of technique of integrating data, putting them together and putting them in a deep time context is part of the use of the Anthropocene in taking these very large, very dramatic recent changes and applying that kind of science to them. And of course, what that is doing, that in itself is multidisciplinary. The chronostratigraphic Anthropocene is not simply geological. The Anthropocene Working Group is multidisciplinary. It includes historians, oceanographers, and others, even an international lawyer to look at the wider aspects. And more widely, this version of the Anthropocene, is also being looked at also by historians, philosophers, and so on. So it is effective in that way. And there's another way to look at this. What happens if the Anthropocene is not formalized? And we keep including all of the present changes that have taken place over the last 70 years, and are continuing in many ways to change place. What will happen to the understanding of the Holocene? The Holocene so far has a very precise identity and characterization. It is stable in the sense of climate and sea level by and large, with small fluctuations, some of which have been used to help subdivide the Holocene. In that, and it has been stable while all the kind of things described by Earl Ellis and his colleagues have been going on. So one can have a whole wide range of human impacts taking place on a planet without fundamentally impacting its basic planetary control systems, like climate, like sea level, like biodiversity. And so all of that was going on with this very rich archaeological record and so on. And then suddenly something changes, as again has been shown. The bottom line shows the radiative forcing from greenhouse gases. That is equivalent, now that's been measured as something like 3 watts a meter since post-industrial. Most of that is going into the ocean. That is a continual process. Every second, there is the equivalent of about 4 billion mugs of very hot tea being poured into the ocean. That's my translation of the zettajoules and so on that are used to measure these things. But that is a very large change. It is leading already to a very sharp increase in sea surface temperature, the top graph, and is just beginning to alter sea level, which lags all of them, of course, which has stayed stable to within 10 centimeters before pre-industrial times over the last 3,000 years. In that. So as these changes progressively take place, the meaning of the Holocene will widen out, become less specific and less useful. And again, as a wider consequence, there is clearly something very big taking place, and that's very recent. And Paul Crutzen's hypothesis, it's essentially a hypothesis that he proposed that the conditions of the Holocene are over, is essentially correct on that. If that is not formalized and is not there to be part of the language used by the IPCC, the World Wildlife Fund, IPBES, and other major groups of scientists working on global change currently, that may impact negatively on how geology as a whole is viewed by those communities and perhaps more widely in that. On the other hand, if a useful term, a limited term, of course, it's not the whole history or anything like that, but a useful limited descriptive term is added that can help those wider studies, then that might help geology too in that. So with that, again, thank you for your patience in listening to yet more of on these Anthropocene patterns, but I'm happy to take questions and be involved in any discussion for Lucy's and my contrasting views on this.
Thank you both for very erudite arguments for and against. Let's start, if there's any questions in the room first. You'd like to ask Lucy or Jan, if there's anyone who has anything particular, and then we'll open it to the online audience. Anyone like to make a comment? We'll go. We'll go. Could you just announce who you are with the microphone? Thank you.
Okay. So I'm Daniele Scarponi from University of Bologna and paleontologist. So Jan and Lucy, thank you very much for your presentation. And my question is, actually it's to both of you essentially. From what I understood is, you're trying to, we have to find a name for two different concepts. One is essentially, multi-sourced, long-term, time-transgressive phenomenon, and the other one, and that its impact on natural system. The other one is the ability of human to interfere deeply with the Earth system at global scale. So both of you, you're essentially, we have to find, to define the Anthropocene by choosing between one or the other of the two concepts. I think, the other one won't be washed away. It will remain. It's only a matter of, find a new name for it. So, and what I'm asking you is if common usage of the term Anthropocene, so looking at the usage of Anthropocene as a term, so can we use, or in order to decide where to attach that name to one of the two concepts, can we use, how the term is used right now? So it's more widespread, the usage of Anthropocene, that means essentially time transgressive and complex phenomenon that, or it's more used, Anthropocene has a term that's saying essentially define the capacity of humanity of interfering at the global scale. So then the other one, if the common use is the global scale, maybe would be that the meaning of Anthropocene, and the other one will find another term, or vice versa. Is this that a criterion to decide, how to use Anthropocene? Because, the two concepts are valid. Great acceleration won't be deniable, so it's full of, full of proxies saying that. So it's only a matter to decide which term is better, so where Anthropocene should be applied to, not, to avoid the other concept. Thank you.
Yeah, who has custody of the name?
Yeah, essentially, talking about divorce,
Well, I guess I'll start off and simply say that as long as Jan shows a picture of the Anthropocene and going into the future, he can't have it as a geologic epoch. He would like to, but it's not, because there is no geologic record of the future. So you either have to take it off your picture or come up with something else.
Jan, as part of the divorce agreement, would you be happy with that?
Well, if the thing is that the Anthropocene, the evidence for the Anthropocene, if you were simply not to think of its future repercussions at all, it would still be there. I see the changes have already taken place. We already have a Pliocene atmosphere as regards atmospheric carbon dioxide. We already have a different heat balance to the Earth. We already have scrambled biogeographic patterns which have been in place before that for tens of millions of years. We already have sediments around the world with plastics in them, with fly ash in them, with all manner of new novel compounds, organic, inorganic in them. It's all there. One could stop right now, today, and say it is, that won't remove the changes that have taken place over the past 70 years. And of course, the reason, only for doing this very limited and conservative look ahead is to say, how significant is this? Can this all stop, unravel, and go back? That's the major question. But if you want to leave that question out completely, all of the features, the stratigraphic features, the strata are there. They can be dug into, analyzed, as they are being done by the GSSP teams and in there. And it's a great question, I found. I think there are two very distinct concepts there. They're not quite chalk and cheese, but very similar to that. It is, they are quite distinct in that. And of course, both are real and both deserve a name. The Anthropocene Working Group has argued that, firstly, Paul Crutzen and the whole Earth system science community got there first and was using the term for the best part of a decade. before the geologists got involved. And there's a whole track record of publications going back to that. The geologists started using it essentially in the sense of Paul Crutzen in that. And he was, of course, part of the working group involved in that, as were others of that community. And the new, if you like, the wider meaning, the ballooning out of the term Anthropocene to mean these other things is really from about 2010, 2011. And if one wished, one could go into, into the statistics of who uses it for what. But I think there is a case of a priority in there, and a priority isn't always, the deciding factor. But there's a strong case that this idea, originated in that form, and it's been preserved essentially in its epoch state. And of course, the name, the name is Anthropocene. It is an epoch-ending name. So to give an epoch-ending name to something that is not designed as an epoch, to something that is designed as diachronous, fuzzy-edged, and different things to different people, again, seems not to make the greatest sense to me. And there are now at least 100, over 100, synonyms for the Anthropocene that have been devised by various people. Again, they're all free for use for other Anthropocene-related concepts.
And I'm of the opinion, but I wasn't there then, that the original concept included the future.
No, well, I say the original concept.
Yeah, before the geologists got involved. Before geologists got involved.
It was the present. It was the present. Clearly, because when one thinks about the present, one also thinks about the future. But the original concept by Paul Crutzen was on changes that had taken place to date, by the year 2000. So he was quoting changes to livestock, changes to biology, changes to atmospheric chemistry, of course. So it's already things that had happened. It wasn't, if these carry on, then we'll have an Anthropocene. It's already here.
And it's not going away.
Yes, it's not going away. And the stratigraphic record is quite clear. There was a very good question a couple of days ago by saying, what is going to happen to, again, thinking future, but this is geologically thinking future, how much of that will be left, once you have erosion and transgression and all that kind of thing? That's a great question, and one could work on it, but it also very much applies to the Holocene as well, and the parts of the Holocene in that. So it's a wider question, of that. But again, using your very sensible statement of let's just think up to now and not think about the future, that again, we can put to one side for now.
Thank you, Jan. We have a comment, I believe, from Francine.
I have a quick question for Lucy. You mentioned that you didn't think that we had the right start time, but you didn't really expand on that. What would be a better start time, according to you? It was on your last slide, I think.
Yeah, well, yeah, I quite agree. I mean, I could put it back up, but
that's all right.
You saw yesterday the list of possible start times, and the bottom on the list was no particular start time because it's diachronous. That's my favorite start time.
Okay, so yeah, okay.
Yes. Could I just come in on that? There is a strong case to be made for that. But of course, that wouldn't be chronostratigraphy. But there is if you like, a partly overlapping biostratigraphy and lithostratigraphy. So your suggestion of a human biozone, is something that would work exactly like that. but again, this is the way that geology works. So one can have a human Homo sapiens biozone or ignosome, but of course that would not exclude an Anthropocene chronostratigraphic unit, because as with all geology, they would simply interlock with each other in the way that all biostratigraphic, lithostratigraphic, and chronostratigraphic and other stratigraphic units do.
Well, Francine put her finger on it, is I don't think the Anthropocene serves the scientific community best as being considered a chronostratigraphic unit. I think you can force it into a chronostratigraphic unit, but I don't think you should force it into a chronostratigraphic unit. You see what I'm saying?
Yes, I'm seeing. I'm trying to. You know, it's again, it's a super question, but I'm trying to wonder how isn't it the number of proxies and the way they line up and the way they can be traced across from land and sea. I mean, I can't think of a clearer, sharper boundary. Possibly the Cretaceous Paleogene boundary, possibly. But even that is hard to recognize in, you know, the southern hemisphere and so on. In that, but certainly all of the boundaries I've worked on in the Silurian, as in the more recent part of the column, they're all fuzzier, more difficult. You know, they don't work as well as that. So technically, the Anthropocene is rather easy to define. You know, of the GSSPs that are being studied, a very good number of them would easily make a very good GSSP. So we have an embarrassment of riches with them.
Because I'm coming from the other direction. I mean, the best example, and I think it was Colin this morning was bringing it up, of the PETM. I've studied the PETM in detail, and I would never think of naming it as an epoch. It has, you know, a precursor. It has a chemostratigraphic signal. It has a duration. It has little details in its duration. And if you're lucky, you even get out of it. So the PETM is a wonderful example of something that everybody knows what you're talking about, but you don't have to name it as an epoch or stage or in anything.
Yes, but it is indeed, it is the marker, you know, for provides the separation between the Paleocene and the Eocene, and in exactly the same way, you know, the series of the event array, the Great Acceleration Event Array, as Colin described, is introducing a world which will have similar duration to the Eocene. I mean, it's not just the PETM. The fact is that the PETM made the change from the Paleocene to the Eocene world, and therefore you do have the two epochs. So that is the analogy. It's not simply the spike itself. Had the spike come and gone and left the world as it was, and of course, you're right, it would be just yet another event, you know, a nice little correlation marker. But again, just to go to this dangerous ground of looking into the future, one can say that a number of the changes that have taken place, particularly the biological ones, must by now be irreversible, large, and sharply delineated. And whatever will happen, you know, will happen. It cannot go back to a Holocene style. You know, even that had been an anthropogenically influenced, it can't go back to a Holocene style biostratigraphy in that, you know.
Yeah, and I'm just talking semantics, that I don't equate the Eocene with a PETM. They're two different things. One's a part of the time scale, one's a phenomenon that was used to help make the time scale. But they're two different things.
So they would be comparable to the, if you like, the Great Acceleration Event Array, which is the PETM equivalent, you know, all the events of the beginning of that, and then the, you know, the Anthropocene as the unit just beginning out of that. I mean, it will be similar, I think, again, just to take that, will be to land on Earth, with appropriate observational material, let's say 70 years, after the impact of the meteorite onto the Yucatan Peninsula. And being able to see that much of the Cretaceous world and the Cretaceous patterns had been fundamentally altered. Having no idea what would come, one would still say, well, let's wait a few million years and keep on calling this the Cretaceous. Or one would say, has the planet fundamentally changed already, and therefore it needs a new name? That's, again, a comparable analogy. Yes. Yes, I'm aware there are other people. Hogging maybe.
It's not the Jan and Lucy show.
No, it's a great TV show. It's there's an online question from Catherine Russell here. Catherine, can you hear us?
Hello. I just sort of wanted to comment on the geologists cannot think about the future thing, because I find this to be quite difficult to get my head around, because I understand there's no record of the future. It makes perfect sense. However, every single thing that I've ever done in geology has had some element of predictive model. And indeed, my PhD was in developing predictive models, which in itself is all about the future. We as scientists, we observe changes such that we can figure out the cause and effect mechanisms. And we know what cause and effect mechanisms are, for example, of sea level rise at the moment. It's a big complicated change. And in fact, in the 60s, humans were retaining so much water behind dams that they caused sea level to not rise for a few years. And that's a global signal in the eustatic sea level change record. We understand, therefore, that if we did that again, not that we can, because we've run out of big rivers, but if we did that again, then we would expect a similar sort of signal because we understand the cause and effect. So by you saying that we can't think about the future, you are actually, I think, saying that no subject can think about the future, which is very dangerous when we're looking to use, even if we were to use the Anthropocene to enact a global change and get people thinking about, well, what are we doing to the planet? If we're not thinking about the future in any discipline, this is incredibly dangerous. And yeah, as a surface process sedimentologist, I look at uniformitarianism. Of course, the present is no longer the key to the past, and we've got to understand what the present is telling us so that we can understand our predictive models as they would have related in the past.
And I quite agree, as geologists, we do everything we can to help study the past to give us insight into the future. But they're two different things. One is something you can touch and one is something that you can't. When you're talking about rocks. Or in stratigraphy, a lot of things you talk about what is observational and what is inferential. I just like to keep my terminology straight. But I quite agree. And that's why I'm against formalizing, because I'm afraid that formalizing it either changes the meaning of geologic time to include the future, which doesn't make any sense to me, or limits people's studies.
Yeah, I think you're completely right that it doesn't make sense for the geological time frame to include the future because it, hasn't happened, so the record cannot exist. I understand that. But what you're saying about the difference between observation and inference, those two things are you cannot detach them when we start looking for predictive models, because we make the observations to create the inference, not create, demonstrably figure out the inference, so that then we can have a good idea of what is going to happen and therefore where we need to take action. I work on plastic pollution. If I didn't have predictive models, I wouldn't know where it's going to gather and I wouldn't know where to go clear it up. We must have predictive models. And yes, even though if something's just been deposited seconds ago, it's, history and things. But we must be able to include studies of the future so that we can understand how geology can be used to help the future. And it's not just geologists that you know, need to be thinking about this. And by limiting geologists in our ability to think about the future, you are not just limiting geology, you are limiting a lot of other disciplines. So I just wanted to dip in and say that, because I do think that there are some potentially dangerous outcomes of that.
Well, I'm one who likes analogies. So do you think historians should write science fiction? Sure, historians can write science fiction, but don't call it history.
Historians can write science fiction. I write science fiction. I love science fiction. I don't see how science fiction has anything to do with the facts and the evidence, the observations, and the future predictions that we are basing off decades and decades of evidence collection and lots of very tangible data. I don't think science fiction has got anything to do with this.
Thank you, Catherine. I should also just go across to Emlyn, has just been waiting for quite a while online with a question or comment. Emlyn, can you hear us?
Yes, I can. Thank you.
Thank you.
Thank you for the opportunity just to make a comment. I'd like to make my comment in the context of a statement that stayed with me from the Berlin meeting at the end of May, and also to look ahead to next year's meeting on the theme of science and humanity being held in Washington, D.C., the annual conference of the American Association for the Advancement of Science. The comment that I'm referring to back last May was that, with which I felt uncomfortable, was that the statement was made that geologists' decisions are not necessarily accountable to the public. I think that that's something that I don't agree with, and so the session that has been proposed, and it's not known whether it has been accepted yet, but in the geography and geology part of the AAAS meeting proposal process, there is a session called Whose Anthropocene Is It? That several on this call, on this meeting, will know about it because they're involved in it. I was on the phone calls to sort of think about it, but Earl Ellis and Martin Head and Lucy and Jacqueline Gill are in the session in the limited availability of the number of speakers and proponents. The sentence that begins, "Why is this a relevant theme to science and humanity?" is, and I quote, "The Anthropocene is now central to scientific and popular discussions on the role of humankind in shaping the world as we know it. Science for Humanity will likely inspire Anthropocene titles, and this session is trying to be different and say that between the speakers, Martin Head and maybe Lucy, that there is this unresolved controversy about whose Anthropocene is it." What I'd like to just sort of say in that context is that, that meeting will hopefully attract thousands. I've noticed from my video viewpoint that I think you've got maybe 20 or so in the room there in Florence, and you've got, as by my count, some 20, 25 people participating online. There was a similar number, I think, in order of magnitude in Berlin at the end of May. So, this discussion is happening in a relatively small, perhaps by most standards, very small scale of forum. But, this is not a secret. This discussion, this controversy is going to be thrown open in front of the world of the AAAS, arguably one of the world's largest meetings under the theme of science and humanity, in a session that's yet to be approved, but hopefully it will be next year. So I guess what I just would like to add is that I think that the Anthropocene, with all of this clear bifurcation between its stratigraphic connotation and its cultural connotation, which is just another way of sort of trying to pull apart the ends of the continuum here, or maybe not continuum, that I think they're not continuum, a wrong use of word, is that I think we are approaching what is probably going to be perceived increasingly in the future by science and society, science and humanity, as a term on par with some other major labels that have become fixtures for looking back at human history, whether that's the Renaissance, whether that's a relatively precise event like the Great Depression, or whether it's World War II. I talked about some of these things in a recent paper, but most of the things that we've named so far have been human historical events. And I looked into the literature, and so in the website Making History Now, the author recalls that the sociologist Philip Adams has argued that an event is not simply, quote, a happening there to be narrated, but rather a happening in which cultural significance has been successfully assigned. In other words, events don't just happen, they're treated partly in hindsight, shaped by processes in retrospection and commemoration. World War II had a similar origin. It's not for one discipline, the geologists or historians or archaeologists, to be responsible for the putting of a name on what has become a massively pervasive, permanently called event. And I think the Anthropocene is in that category. I guess the Anthropocene Working Group, you could say, has done such a great job that the term has become so popular, so transdisciplinary, that in fact it's being editorialized by the New York Times and The Economist and The Guardian. That happened within a couple of years of Paul Crutzen talking about it, or when the AWG was first formed in 2008 in London. The point is that the term has gone above and beyond and around us as whatever discipline we have, and it's now, whether we like it or not, it's imminently, I think, going to take its place as a label for a great chunk of very significant time in the history of the planet. Those other ones I just mentioned have been all about human historical events, the Great Depression, the World War, the Renaissance. But what I believe is what geology can do very usefully is be very proactive in presenting and advocating for the Anthropocene as an event that is very educational about the entirety of the time in the Earth's history when human life started to move away from being forced in the same context as wildlife, a phrase I've used earlier in one of these points. So I'm very much in favor of the kinds of discussions that have been added this morning by Earl and by Lucy, and I hope that this session is approved for the AAAS next year under the theme of science and humanity. This needs to come out of the closet of the AWG, if it's in fact in one, and be moved right out onto the front of the room, in front of the world of science. And I think let the chips fall where they may. But I think the term, it will not hold as a tightly controlled term in the purview of geology.
Thank you, Emlyn. Martin, would you like to respond to that, or Jan?
Could I just, very quickly suggest that, on that, one thing it would be very nice to do is, this is, the focus on the Anthropocene can obscure a few other things, and it would be nice to have focus on the Holocene, because as it's maybe not a term that Earl uses very much, but it is a record of a planet over 11,000 years, which has got all manner of human impacts on it, recorded, a wonderful history of that worked out, and yet the fundamental planetary systems, nitrogen cycle, carbon cycle, phosphorus cycle, all of those, sea level, climate, held steady. And I think that in itself would be a very useful thing to explore in this context, because then, again, as Paul Crutzen said, the Anthropocene makes sense as a counterpoint of comparison to that. Again, I think we have to break open these ideas in order for them to be widely useful, and certainly focus on the Holocene in that sense, would be helpful here.
Yeah, and I with respect, I'm not understanding how what you just said relates to, if it meant to, but if it does, how does it relate to what I was just saying? I don't get the connection, I'm sorry.
In the sense of, if you like, you're trying to get wider public understanding of important aspects of Earth history. And you know, the Holocene as an entity, I think has got very important potential, you know, here in that, you know, as many people said, it's often forgotten, you know, in the rush for the, you know, for the more dramatic Anthropocene. But the dramatic Anthropocene only makes sense if it's compared with another state of the planet, you know, and of course the whole of geology and the units derived from that represent different states of the planet.
Thank you,
Sorry,
Jan.
I'm hogging again, so there are other questions, and I think Martin had something to say.
Yeah, thank you, Jan. We'll go to Martin, and also I'd like to go to Charles Turner, who also has his hand up. We'll go to Charles in a minute once Martin has made a comment. Thank you.
I very much enjoyed the talks and the discussions this afternoon. We seem to continue to return to this kind of entanglement of concepts and terms, and I think we've got separate concepts, and we're using essentially the same term for these different concepts, and I think we keep getting caught up in this. So that's my first comment. Related to that, yes, is the very good question: who owns the Anthropocene as a term? Well, one could also ask, who owns the Jurassic? Well, the answer is nobody, of course. But we all know what the Jurassic is because it's been defined. Well, maybe not by GSSP yet, but it has been defined as a chronostratigraphic term. So we know what the Jurassic is. The problem, in a sense, with the Anthropocene is that because it's been essentially adopted by a number of different scientific and scholarly disciplines, it's kind of bled out into the academic environment, is being used in different ways. But those people who understand that it takes time, in the case of the geological timescale, to define these formal chronostratigraphic terms, I think they would understand that, given that time is required, if the term were formalized, I don't think it would actually take very long for its usage within the pure sciences and also within the social sciences to stabilize. I think very quickly the Anthropocene would be understood as a technical term to begin at around the year 1952 or whatever it is. Now, it may be that in the humanities, the usage of the term Anthropocene would continue to be used in various ways. But I do think that the confusion that we're seeing within the sciences and social sciences with respect to the usage of the term Anthropocene would be clarified by formal definition. Now, there would be another benefit, of course, to formally defining the Anthropocene chronostratigraphically. It would give due prominence to the Great Acceleration. And that, of course, I mean, we can't deny that will have social benefits as well. Now, Earl has already said, well, you don't need to define the Anthropocene chronostratigraphically in order to, if you like, explain to the world the importance of the Great Acceleration, because the evidence speaks for itself. Everybody knows about the Great Acceleration anyway. Well, the coffee machine downstairs takes euro coins, and I don't have any. So instead, I decided to look up the Web of Science, Clarivate's Web of Science, and I decided to see how many citations the Holocene has received. About 57,000 citations for the Holocene. Pleistocene, earlier you might be pleased to hear, is a little bit more, but not much. But then the Pleistocene is, a couple of million years, whereas the Holocene is only 11,700. The Anthropocene has received over 10,000 citations. The Great Acceleration, on the other hand, as a term, clocks in at 209 citations. So actually, even within the scientific community, the term Great Acceleration is not widely known. And I bet if you stopped random people in the street, or even within this university, you would find that most students have never heard the term Great Acceleration. Now, were it happen that the Anthropocene were to be formalized, then I'm sure many, many more people would understand either the Great Acceleration itself or the fact that the Earth's planetary state has shifted to the extent that a new geological epoch has been designated for it. Okay, so what happens then if we don't formalize the term Anthropocene? Well, the Anthropocene as a chronostratigraphic term will continue. It will just be another different kind of Anthropocene, but it will continue because it's still being used within the Earth system science community. So it's not as though the work that's been done by the Anthropocene Working Group will be suddenly kind of nullified. It will still be out there. It will still be in the literature. It will still be influencing people. But the muddle will continue. And it seems to me that by formalizing the Anthropocene, this is a means, apart from all the other advantages we've talked about, this is a means of clarifying the term. Now, you might argue, oh, well, some people will continue to use, even in the sciences, some people will continue to use the Anthropocene in a different way. I beg to differ. Now, when we redefined the Quaternary back in 2009, the Pleistocene base shifted from 1.8 to 2.6 million years. And of course, there was a great deal of gnashing of teeth because people said, well, many people won't go along with this. And, within a couple of years, everybody was using the new base of the Pleistocene. They were using the new base of the Quaternary. Because, above all, people want clarity. And formal definition provides clarity. We define the term, and we get our lives back. We can move on. We're just now using these terms as sharpened tools. And there's no more to it than that.
Thank you, Martin. So, we can only do so much about time. Stratigraphic time, but we are up against an immovable force of time related to the closure of this room. We've been told we need to leave by past. Now, Charles has been waiting very patiently to ask a question or raise a comment, and so I'd like to go over to him, but we do have limited time now. In fact, we have about 10 minutes before we have to vacate this room. So Charles, if I can go to you, and if you could raise your question and comment, then that would be great. I should also add that this is not the final meeting. This was a meeting, and it's just responding to Emily just very briefly, just in terms of numbers of people here. This was a meeting that was organised to communicate with members of the Subcommission of Quaternary Stratigraphy. And so they were effectively the primary audience we were hoping to discuss and relate to this, which we have achieved in some form. They are a limited number of people to talk to. This is not the last meeting. We will be discussing the Anthropocene for a lot longer than the end of this year, with the SQS, with the ICS, and with the general public, and anyone else who wants to talk about the Anthropocene. Since its inception, the Anthropocene Working Group has discussed this to great detail with different disciplines and with different people and different scientists. So this is an ongoing conversation. So I'm just going to hand over to Charles now. So Charles, I hope you have a very short question, but perhaps we can elaborate on another time as well. So over to you, please, Charles. And I think you need to turn your microphone on. Charles, if you can hear us, you need to turn your microphone on. Charles, yeah, we can see you, but we have no, we cannot hear you. Oh, there we go. I'm afraid you've gone again now. If you can, Charles, if you can hear me, if you press that button that you did a second ago that we could hear you very briefly.
Could you just send a message?
Yeah, Charles, if you could perhaps send a message in the question in the chat function. I'm sorry about this. I know you've been here throughout the meeting, and I was very much looking forward to hearing your comment, but yeah.
Perhaps whilst that's happening, maybe because we've only got 10 minutes, if we could start 5 minutes, perhaps we can start to wrap up, and when the questions come, we can then turn to that. I suppose the first thing I need to do is again thanks Adele for all of your efforts to make the meeting possible. Without your contribution, we could not be here today. And to everyone in the team as well, who's with the hybrid connection, generally it's worked very well. The odd question we've had problems with, generally it's worked excellently. So thank you for you and your colleague for your contribution. Again, thanks for all those who've actually physically here. We've got some working group members who've gone to great efforts to make the appearance here today, and for all those who've been online as well for your contributions. And from the University of Florence, for your input as well, because again, having numbers of people asking questions and new questions, ones we've not maybe faced before, broadening our understanding of the term and the terminology is always invigorating. Having the chance to go to the museum yesterday was also spectacular. So thank you, first of all, to all of you for that. As a brief summary, I guess at the end of the day, we have a fixed role. You know, this is being asked of us by the SQS to investigate the Anthropocene as a potential geological unit. We have done that. I think we've done that eminently over the last 12 years. The number of publications, the public meetings we're holding like this demonstrate that we've gone through all of the protocols that are expected of us, and that we are following those protocols, and yet at the same time they're maybe being used against us because we are having to work to guidance that's been given down to us and is applicable to other geological time units as well. So yes, we do spend a lot of time focusing on this 1950s great acceleration because protocols require that the definition of these units is based on a fixed boundary, but the boundary itself represents demarcation between the unit above, which has one characteristic, and the unit below, which has another characteristic. So what we're not doing is focusing purely on that boundary. We're having to consider what does the Anthropocene as a body of sediment, of material, how does that differ from the Holocene? And so when people say, oh, you're just ignoring, you're disregarding human impact in the Holocene, no, we're not. We're considering that, and that's the difference between those effects that we see in the Holocene and those we see in the Anthropocene are very much fundamental to the recognition of that boundary. So we do not disregard anything, and also we do not consider that the Anthropocene is some way superior to the Holocene. It's just another characteristic of geological timescale. And to try and denigrate the evidence for the Holocene, I think is disrespectful in many respects. Maybe just another comment. Have we got Charles's comments yet? No. No. But another thing, Lucy's presentation, it reminded me of something that happened in our first meeting of the AWG in Berlin. And Lucy mentioned many times about humans dominating the planet. And the meeting we had in Berlin, and Jan will perhaps remember this, every time someone said that, everyone else said, no, you can't say that. You shouldn't say we dominate, we're influencing. And so for probably a year or so, every time we wanted to say dominate, we said influence. And it's surprising, or maybe not surprising, but over a year or two, that hesitancy to use the word dominating, humans dominate the planet, the evidence has become quite clear that this is the situation. And I suppose the question you've got to ask yourself is, at what point do you feel that we went from a species which is influencing the planet to one that's dominating? And can you provide a date to that? And has having a geological boundary at around about 1950s got any relevance to that debate?
Charles, would you like to join us very briefly?
3 minutes.
We have about 3 minutes, if your microphone is...
Slightly appropriate, and it's a question of whether you regard human influence as important. And I'm thinking back to my old mentor, Richard West, who maintained that the Holocene was really simply another interglacial. And he used to quote Lyell, who said that the definition of the Pleistocene was all post-Pliocene time, and that he at one point said, well, don't use Holocene, just use Flandrian as an interglacial. And Flandrian rather than Holocene, and regard that as something. In other words, you're ignoring the human you're ignoring the human ideas connection completely, and just saying, well, it's an interglacial, and indeed things like the vegetational development as it's got and the climatic development initially are very much like other interglacials.
Thank you, Charles.
Just as another point, and I think it was Catherine Russell was to some degree discussing this, was that there's a tendency by some people to keep thinking about stratigraphy and geology as deep time rocks. Lucy particularly is talking about rocks. And I think there's a danger here that we start to make geology seem as if it's something that's not relevant to the present day. And as a science, we need to demonstrate there's some purpose to what we're doing. And I think the Anthropocene is a wonderful example of how not just geology, but other scientific endeavors allow us to bring together a clear understanding how we are currently changing the planet. And as Catherine said, that then also provides a way of understanding about how we could potentially change the planet in the future. And as Catherine also pointed out, that this idiom of, that the present is the key to the past, maybe we have to start thinking about, is that necessarily the case? We looked at the Mississippi River in particular in 2019 and said, well, is the current morphology of the river system that we're seeing in the Mississippi really a good model for the Holocene Mississippi? So there's a point here of saying maybe we've transferred or transitioned the planet into such a different state that we can no longer use what we're calling that Anthropocene as a good model for the past Holocene human impact. So
I think in terms of a time we have, thank you again for everyone who joined us remotely and in person. I have pages of notes of questions I will be asking people for the next few weeks, years indeed, I think, to continue this discussion. But I think for now we're going to make this meeting, we're going to close this meeting, and well, thank you very much for coming.
Thank you.